Hello guys, welcome back to my channel, Mason African Motives. Still working on mathematics for O level. So in this platform we have got the question paper from the November 2016 paper, which is actually paper 2. So we just want to see guys how we were supposed to attempt these typical questions that we had. So we shall quickly rush through the questions. So guys, if you're new, you can consider being part of the family by subscribing and also sharing the videos to your colleagues so that they also can benefit from this information that we are having. Let's grow as a family. Let us try by all means to share our platform to your friends so that we can grow as a family of Mason African Motives. Okay, so without wasting much of your time guys, let us quickly rush through the first questions that we are given. Here we're just given to expand, that is to remove the brackets and to simplify on 1.1, which is on section A. So we have got this question that we are given, that is A minus B. In this case, that is what we have got here, into 2A minus B. All right, then we are given to simplify, that is to expand. So whenever you're given such type of equation, as you can see, these are brackets that we have. So whenever I'm given brackets, I'm supposed to expand. So in this case, A is going to multiply everything here, so you can actually expand like this. 2A minus B is this part going to be multiplied by A, then minus B is going to multiply 2A minus B, just like that. So if you are to expand guys by A, that is 2A squared, A and minus B, which is minus AB, that's this part multiplying each other. Then here it's going to be minus 2, but take note here, yes, it's B and A, you're supposed to write it like this, minus 2BA, but take note you have written here as AB, so just maintain that order so that you don't confuse yourself when it comes to simplification, where now you want to collect like terms. All right, then we've got minus B and minus B, which is going to give us B squared. So this is going to be B squared. Now we have got our like terms, that part now we need to collect like terms on AB and AB on this part. So this is minus 1 AB minus 2, so simply minus 1 minus 2, which is minus 3 AB plus B squared. So at this stage we do not have any like terms. This is A squared, this is B squared. These two, they do not have any relationship, so we are not supposed to simplify at that stage. So that's what you had guys. Let's see the item B part that we are given. So this question guys, I actually saw like it's a division. I don't know what it looked like from a question paper, but that was actually a division, that one. All right, so the question was like this, so you can concentrate. This one was a plus. All right, so that was the question. We are asked to simplify this this fraction that we're given. So definitely I can start by rearranging my numbers into improper fractions so that I can simplify better. But as we are doing that, we must mind that we are going to be applying our BODMAS. So I will say guys, we have our BODMAS which still exists, and some can even use this as BOMDAS, as BOMDAS, like that. So it's still one and the same thing. So what you're supposed to take note is that, okay, I am given brackets in this case, that is from this part that we have got here, we are given these two brackets. So these two, they are going to add, then we divide later on, because we have got brackets here. So we are going to start with these brackets, but as we are doing that, let us be simplifying this part, which is 8 plus 1, which is going to give us 9, multiply, then add, which is 9 over 4, divided by, we simplify this part, we multiply, then add here, that's 4 plus 1, which is 5 over 4. Here we are going to obtain 9 plus 1, which is going to be 10 over 3. All right, so that is what you're going to have. And how can I simplify further? Like I said, it's a bracket, yes, that you're going to have. So it's going to be 9 over 4, which is going to, for this moment, this division is going to respect this bracket. All right, so we are going to start by simplifying this way. We've got to add and find the LCM of the given two numbers, or the LCD of 4 and 3, which is 12 in this case. So as you can see, 4 divided by 4 into 12, that's going to be a 3. That is 12 divided by 4, which is 3. Then you multiply here, which is going to be 15. As you can see, we've got 5 by 3. Okay, as plus 12 divided by 3, which is going to be 4. The 4 that you get, you multiply to 10, which is going to be 40 here. So you can add the 2. So the moment you are simplifying in this bracket, which means there is no need for us to write this bracket. All right. At least what we just need is to simplify further so that it can give us an exact value. So you can add these two, which is going to give us something like 55 here over 12. All right. So as we know, guys, we are just left with division there, and we know that whenever you've got a division, we have to introduce multiplication so that we are able to simplify further. So this is going to be 9 over 4 multiplied by, the moment we introduce multiplication, what are you doing? Inverting the second fraction, which is now 12 over 55. All right, so it's now you and your reducing techniques. By 4 here, that's 1. By 4 here, that's 3. So we can multiply here, which is 27 over 55 by 1, which is 55. So as you can see, we do not have anything that is common. And also, guys, this is actually paper 2. So these things, guys, the moment you indicate this stage here, add, okay, all this part, you can even use your calculator. There's no need for you to even show this process. All right, because this is paper 2. Some of the stages you have your calculator there, so you can be using the calculator. It's fine. Then on 1C, we're asked to express as a single fraction in its simplest form. So as a single fraction, we are simply applying all the techniques of what? Of addition and subtraction. All right, so this is our C, where we are given 2x plus 9 everything over 7 minus x plus 1 over 28, like that. So as we know that if we are to simplify in this case, we have to find the LCM, which is the LCD of the two given fractions. That is the denominators in this case, that is 7 and 28. So what is the LCM of these two numbers? We've got 28 in this case, that is our LCM. So you can divide 28 divided by 7, which is going to give us 4, and this 4 is going to multiply everything here, which is 2x plus 9 minus 28 divided by 28, which is going to give us 1. But take note, there is a minus, so it's going to be minus 1 into, it multiplies everything in the numerator. So you are supposed to open these brackets because this part is supposed to, you are supposed to multiply each and every term that is given there. All right, so let us expand, guys, each and every term. Now multiplying by 4 and 2, that's 8x, 4 and 9, which is going to give us 36. Okay, we move on, minus 1 and x, which is minus x, minus 1 and 1, which is minus 1. Take note, it's a minus and a plus, which is going to give us a negative, everything over 28. So that means we are able to simplify like terms. So which are the like terms? We've got x here and x, so this is a 1 here. So it's 8 minus 1, which is 7x, 36 minus 1, which is 35, everything over 28. All right, so at this stage, make sure that you cross-check the numerator if there is anything that is common there, so that you can factor out or you can factorize. So in this case, cross-checking 7 and 35, we can see that 7 is the highest common factor. So I can factor out 7, that's 7x divided by 7, which is x, 35 divided by 7, which is 5 in this case, everything over 28. So for you to be able now to notice that this number is the highest common factor, for you to be able to notice that, it means you must be very, very good in your multiplication. That is where you're supposed to be very, very good in your multiplication there. If you know that 7 times 5 is equal to 35, then it's easier for you to see that when you have got a 7 like this, that is a number that is related to 7 that gives me 35. But if your multiplication is not as that good, then this procedure, most of you, that's where you just leave at this stage. You think that there's no number that is common between these two numbers, you see now. So be very, very sharp in your multiplication. It can help you a lot. And also, due to that same multiplication, it is the same multiplication that is able to tell you that here you can reduce these two, because you know that 28 is a multiple of this 7, and 7 is a factor of 20. So I can reduce by 7 here. 7 into 7 into 28, which is 4. So everything is going to be 1 times x plus 5, which is x plus 5 over 4. So that's what you're going to have in this case. You cannot simplify from this stage. Just leave your fraction like that. Okay, so at this stage everything is fine. So these are the typical concepts that you're supposed to note when you are answering questions. So that's what you had. That's what we had. Let's see on the part D, where we are given that there is a trader who sold a bicycle for $84 and made a profit of 40% on the cost price. Calculate the cost price of the bicycle. All right, so definitely that means to make a profit is from what you have sold, from what you have. We bought something, or you have got something that you want to sell. So the profit that you are making is actually an additional to the percentage that you had at first, or to the price that you had at first before you are selling the price. To say, let's say you've got a pair of shoe that you bought, and you want to sell that pair of shoe. It means the price that you bought that the pair of shoe is at 100%. Then the price that you're going to sell it is going to be at a percentage which is greater than 100%, if it is on a condition of making a profit. Yes, you can sell a product and make a loss. That means it will be at a lesser percentage than 100%. That is when you are making a loss. So what I'm simply saying is that the cost price, the one that you actually bought the let's say the one that we bought the price, the pair of shoe, or you're talking of shirts, or whatever type of business that you want to make, that is at 100%. So you do not know this price that was at 100%, but you know the price that was when a profit was now realized. That when there is a profit of 40%, the price was $84. So a profit is an additional to the percentage. If it is a loss, that is to subtract, you are reducing. So in this case, we've got a profit of 40%. So if it is a profit, we are going to add 40% to the normal percentage that we are used, which is 100. So if we add 40, we are now at 140%, which is the one that corresponds to the amount that the bicycle was sold at. And the bicycle was sold at $84. So if this bicycle was actually sold at $84, therefore what was the cost price, which is the cost price, the one that is at 100%, before any profit was realized. If it was a loss, then it was going to be 100% minus 40%. That is if it was a loss. But in this case, a profit, that is why we have to add. So this is going to be less, as we know. The lesser part is the one that you're going to write on top, over 104. This is percentage and percentage, so definitely they will cancel. Then you multiply by $84. So that's it, guys. This is paper 2. The moment you do this, use your calculator. Don't find yourself now canceling these zeros. This is paper 2. Use your calculator straight. So this is going to give us $60. So you can write it like this, or you can write it as $60. So normally I always tend for you guys to write your answers, especially in a way that was presented before. Like, you see how they presented this answer, this price that was given here. You just present the same way also. So that is the best. Or you can even write it like this: $6. It's one and the same thing. And also the other thing, when you are writing this is $1 more, where most of us we find answering questions using this symbol for dot, this is not a symbol that you use. You are going to use one like this. That's $1. That's one. Okay, so take note how you answer your questions also. But as I explain this, I hope you understand what I'm saying. Find the inverse of the matrix M. From these two matrices, we've got matrix M and matrix N. So as we know, guys, the inverse, we simply need to find the determinant of the given matrix, where I told you that determinant, right, let me write it like this, determinant of M, which is in this case can be written like this, is equivalent to AD minus BC if your matrix is written as A, B, C, and D. So that means I'm going to multiply 3 and 7. That's 3 times 7 minus B and C, which is 9 times what? 9 times 2. Why are we calculating determinant while the question is talking of the inverse? It's a part of our answer that we need. All right, so we need this as our answer. So we are going to find here 21 minus 9 times 2, which is 18. All right, so in this case, if we are to subtract 21 minus 18, we are going to obtain 3. That is our determinant of M. So remember how you indicate your determinant. Now for you to have the inverse of M, we are going to have our matrix like this, guys. 1 over the determinant, which is 1 over 3. So it's 1 over the determinant. Then in your matrix M, remember A and D, they interchange their positions. So these two are going to interchange their positions, which is going to be 7 in place of 3, 3 in place of 7. That is now 7 here and 3. Then in the minor, this is your minor diagonal, the one with 7 and minus 2 is called a minor diagonal. If you watched my matrices videos, I explained all these languages. So that's your minor diagonal. You multiply by minus, that's minus and minus here. So it's minus 9 and minus 2. So this is now the inverse, 1 over 3 into this matrix. Okay. On item 2, there is now a matrix P, which we are not given here. But that matrix P is said, if we are to find it, it must be from this equation. 2P plus matrix N is equal to 7, 3, 4 minus 4. That is where our matrix P is going to be found, from this equation. So how are we going to find this matrix P? Okay, so it's simply, we need to substitute whatever that you are given. There is matrix N here, and we have got matrix N here. So let's substitute matrix N where there is N, right? Let's start by doing that. 2P plus N, that's our matrix N. So we have to substitute our matrix N in this case, which is 5, minus 1, 4, and minus 6. Your matrix N here is going to be equal to the one that you're given. So you have substituted your N where there was N here, then you equate it to this one that is on the right hand side, which is 3, 7, 3, 4, and minus 4 from this equation here. So you just substituted N, then equated to what was exactly on the equation. All right, so there are so many ways that we can actually do this. Some of us, they can, let's say, they can write it like this. Let matrix P be equal to A, B, C, D. Yes, that's what some can do. But we can simply work without even introducing that, because we know that definitely in our matrices, guys, I told you that in order for you to add matrices like this, they must be of same order. So definitely the matrix P that we are talking about is a 2 by 2 matrix. So we just work it like that, knowing that there is a matrix here. So let us transpose this matrix to the right hand side, just like in a normal equation. 2P plus 3 is equal to 7, and you want to solve for P. You transpose 3 and it will be minus 3. But here you are transposing a matrix, it's a plus, so it's going to be a minus. So it's going to be equal to 7, 3, 4 minus 4. Then you subtract this matrix on the other side of the equation here, which is minus 5 minus 5 minus 1, 4 minus 6, like that. All right, so knowing that this is the 2P, which is a matrix, okay, so let us leave it like that. I'm going to explain that one later on. So we're now back to the simplification, normal simplification of your matrices. Subtracting matrices, you know that we are talking of the order of matrix, the corresponding elements. 7 minus 5, which is 2, 3 minus minus. Take note, there is 3 minus minus, so it's going to be like this. 3 minus minus 1, definitely it's a plus. So 3 plus 1, that is 4. You move on in the air, that is 4 minus 4, which is a 0 there. Minus 4 minus minus 6. Take note, it's a minus 4. Then there's a minus that is subtracting the matrices. Then the minus 4 that you're talking about, it corresponds here with minus 6 like this. So it will be minus 4 plus 6, which is going to give us a 2. Definitely, that's what you're going to have there. All right. Now from this case that we are given, what we need is to find the P, which is the matrix P. All right. We know that the 2 there, if this is a matrix, therefore the 2 here, it represents what? A scalar. So how do I remove a scalar? Here I'm supposed to divide by 2 to remove a scalar, but here I'm not going to represent like dividing by 2. It was supposed to be like this. But what I'm simply saying, guys, you must just have this, you must visualize this thing here, that you are simply dividing by 2 like this. 2 into 2, 2 into 4, 2 into 0, 2 into 1. That is what you must visualize. But the actual presentation is supposed to be like this. When you divide by 2 here you're going to write 8 as 1 over 2. The inverse of 2. You divide it by 2. Here you write it as 1 over 2. All right. So your P is going to be simply like what we are talking about here, half of 2, because this is now a half, which is now a scalar here as a half, which is half of 2, that is 1. So simply, if you can visualize it, like, but don't write in your book like this, because this is not allowed in mathematics, guys. You just visualize like this. 2 into 2, that is 1. 2 into 4, that is 2. 2 into 0, that is 0. 2 into 2, that is 1. Just like that, which is the same thing here. Half of 2, that's 1. Half of 2 or half of 4, that is 2. Half of a 0, that is 0. Half of 2, that is 1. So the one we have written in this case and the one we have visualized, like the just to visualize like this, you are obtaining the same thing. You're just obtaining the same thing there. You see, so mathematics, guys, is all about the idea of what you know and application of what you actually understand, especially when answering these typical questions that you must have that mentality. All right, anyways, let us see on number 2 where we are given, it's actually 2b, with continuation. We were given to make M to be the subject of the formula from the equation where x is equal to y plus the square root of m plus x squared. That is the square root of m plus x squared, and you want to make M to be the subject. All right, so how can we actually make M to be the subject in this case? As you can see, the part that has got M is this part that is surrounded by the square root there. So what am I going to do to remove that part? Okay, let us first transpose if possible. I'm just looking for another indicator that I can use here. All right, so we have to transpose anything that does not contain this M from this part, so which means we are talking of this part here. So let us remove this part and cross check to the other side of the equation, that is x minus y, because this is a plus. So the moment you take this to the other side, is now a minus, which is equivalent here. This is a plus, so it's going to be just the square root of m plus x squared. Okay, now we are back to this M which is containing the square root now. So how am I going to remove the square root? So you know that whenever there's a square root, the moment you square this, you're actually removing this. Moment you square, that is the opposite of removing the square root, which means you're actually going to be left with what is inside the square root. But what you have done, because this is an equation, whatever that you do on the left hand side is to be done also on the right hand side. That is the golden rule that you're going to have. So here I have squared by 2, which means actually here I have to square also by 2. I have to square that side. Okay, so the moment I square this part, which means I'm having x minus y squared, which is equal, but remember that we said to square, to put a square like this, is to neutralize the square root, to remove the square root. That is, we are going to remove, to remain with m plus x squared, like that. Yes, you can expand your brackets, but why expanding, guys? Does this part contain m? No, there's no m here, so there's no need for me to expand these brackets. Just leave it like that. What I need is to have m, so transpose the plus here taken to the left hand side is going to be a minus. That means we are going to have x minus y squared, the one that was already on the left hand side. All right, we are starting with this part that is already on the left hand side. Then we transpose the plus x squared to this side, which is going to be minus x squared, and we are going to remain here with what? With m. So remaining with m, that means we can actually write this. Therefore our m is equivalent to x minus y squared minus x squared, like that. So that is what you're going to have in this case. So these are the typical questions that you're going to have in this case. We are given on number C that if Mrs. Pindo pays with 100 Rand note for an item which is worth $2.20, she gets $10 40 change. All right. Actually, from this part, I just want us to understand from what we are given. She is paying something, guys, which is costing. We do not know the cost here because we are just told that she pays something for 100 Rand for an item worthy $2.20. But when she is paying here, she gets $10.40 as a change. All right. So calculate the exchange rate in form of now. That is n rand as to how many US dollars? $1, where n is correct to two decimal places in this case. All right. So this is the case that we can ask ourselves to say, if she is going to get $10 change from what she has bought here in US dollars, what was the price that what was the price of an item? It was $2, but what was the amount now in US dollars? So we can actually calculate the total amount in US dollars here. Total amount in US dollars, which is going to be what? The item price. It was worth $2.20. Let us write here. It was worth $2.20. Then she gets $10.40 as change. So definitely, guys, let's say you bought something for $2. All right, let's take from something that you are used to. You buy something for $2, then you are given change of $3. It means what was the price for that thing? That was 3 plus 2, the change that you are given, and the money, the cost of the price. That is the total amount that you had. Okay, which means you gave or you paid with $5, then for an item which costed $2, then you're going to get a change of 3. So that is the case even here. The item is worth $2.20 and she gets a change of this $10.40. So that's why we have to add $10.40 in this case. So this is paper 2. Use your calculator, guys, to add these two. You're going to obtain $12.60 if you add properly. So this is going to be $12.60. Mind you, these are US dollars. All right. So this is the total price that was equivalent to what Mrs. Pindo paid, but she's paying with a 100 Rand note. Which is this 100 note that she's paying with? It was equivalent to $12.60 for that moment that we are given. So we are going to equate now this rand in the format that we are given, because we are given to say RNS to be $1 US in this case. So this is how we are going to write it. You're going to write in terms of rand, which is 100 Rand in this case is equivalent to, or we can just write as to how many dollars here, how many US dollars? $12. That's gonna be like this, $12.60, like that. All right. So in this case, for you to obtain a 1, because this is a ratio that you're given, so you remember ratio is simply, guys, all right, let me just try to adjust this side, guys. All right, remember this is a ratio where if you are working with a ratio, for you to obtain a 1 here, it means you have to divide by everything that is on that side. which means you are dividing by 12,6 here. The moment I divide by 12,6 on this side, 12,60 here, but just use 12,6 because it's actually 12,60, but just 12,6 is what you're using. It means I'm going to obtain a 1 in this case, which is for the US dollars. But how many right now that I'm going to obtain, which means I'm going to divide these two. So just divide 100 divide by 12,6. That is your amount now in rand, because n is representing any number, but here it's supposed to be 1. It's a fixed value that you are given. This is supposed to be 1. That is why you divide by this, so that here you obtain a 1. Then here, whatever that you're going to get, round off to 2 decimal places, you are going to obtain 7,93, something like that. It's 7,9365, which is, when you round off, it's going to be 7,94 to 2 decimal places now. So this is what you're supposed to write your answer as. Learn to answer the question. So this is your n here. Sometimes they can ask you to say, we are given a rate like this, then the question is calculate the value of n. When the question is asking you to calculate the value of n, you state that your n is equal to, this is your n, but in this case they said you are given to write it as a ratio like this, not 1 US dollar as to, no, this rand as to. This is what you're supposed to write your answer as. All right, anyways, let's see another part on 3a. Now number 3, we are given as a diagram that we are given in this case. So mostly I always tell you guys, whenever you're given these typical questions, just learn by all means to fill in your diagram, whatever that you have with the knowledge that you know. So from this diagram we are given that these two sides, they're equal. AC, AM is equal to AC from this part, A to M, A to C, they are equal, an angle of 26, and all the other angles. So just rushing through the question, we know that AMC is going to be an isosceles triangle, where we know that the base angles are going to be equal. So this angle will be equal to X, since this angle here is equal to X. All right. The other thing is that if you were to cross-check this shape, guys, learn to see the diagrams in another view. Okay, this is N, M, A, C back to N. This is a quadrilateral. It's got 4 sides, 1, 2, 3, 4. So which means angles inside this shape is supposed to give us 360 degrees, because it's a quadrilateral that you have. So we can find this angle here at A. Why? Because we are given 3 angles, 1, 2, 3, and this is your third angle. So you can calculate this angle from 360. All right, that is what we have. So let us answer the first question. The first question is to calculate the value of y. All right, so as we can see, guys, the value of y is connected with this value of a, which is reflex MAC. Okay, so let us start by calculating that angle first. So this is 3a, item 1. So let us start. We want to calculate the value of y, but let us start by calculating the reflex MAC. That is MAC. Okay, so this MAC is the one that I'm saying is the angle that is inside this quadrilateral, and we said in a quadrilateral angles add up to 360 degrees. So that means I'm going to subtract these angles from 360 degrees. So it's going to be 360 degrees minus the angles that are surrounding this shape, which is 26, 42, and 64. That's 26 plus 42 plus 64 in this case. So you're going to subtract these angles from 360. So guys, if you are to subtract properly in this case, you are going to obtain 360 minus 132, okay, which is going to give us 222. This is actually a reflex angle, 228, sorry, degrees, and it's actually that's actually a reflex angle that we see here, which is this one, 228 degrees. That is your reflex angle. All right, now it's going to be easier for us to now to find the value of y, which is this one. Why? Because this is an angle that we know a complete revolution, or angles at a point, they add up to 360 degrees. So which means the value of y is going to be 360 degrees minus 228, which is the reflex, and it gives us back, it gets us back here to that 132, guys, as you can see. So this is going to be 132 degrees. All right, so that is the value of y. Then find the value of x. So x is now easier to find, because as you can see, x here is representing what? The base angles of the triangle, and this y we said it's 132. So you're going to use this isosceles triangle like this. This is the triangle that you're going to take. We said this is 132 degrees. These two sides, they are equal. This is your x here, this is your x here. So how can I find x? I simply have to subtract this angle from 180, then divide by 2, because these two angles are equal. So which means x can be written like this. You can even write it as an equation of x. Yes, you can find it in different ways, but you can even write it as an equation to say that x is equal to the difference of this from 180 minus 132 degrees over 2, because these two angles are equal. So the angle that I'm going to get, I'll have to divide it by 2. Or you can just find your 180 minus 32, you find it separately, then you add x and x, which is 2x, you equate to that value. So if you subtract 180 minus 132, it is going to give us something like what? 48, like that. Then you divide by 2 by 2. So x is going to be 24 degrees. So like I said, you can even just use it here from this equation, which is going to be 48 over 2, which is 24 degrees. So many ways, guys, that we could have done, or we could have used to calculate the value of x in this case. So that is how these questions actually can be presented like. So we are supposed to be very, very careful in attempting these questions, guys. Okay, let's see another question here. All right, this is B, the B part, where we are given in this case the point P and the point Q that we are given, and also there's another one which is R, which are on the Cartesian plane. Then you're asked to find the vector PQ. All right, so guys, remember I told you that when you are given points on a Cartesian plane, when you are given points on a Cartesian plane, for you to find a vector like this one, you're given to find vector PQ, is the Q minus P. You're supposed to write it as a point Q minus P. But remember, guys, I told you this is a vector, so you write it as OQ minus OP as a vector, where OQ is simply the point Q, but just written as a column vector. The same point Q, which is 3, 4, but now just written as a column vector like that, minus OP, which is the same point P, but now it's just written as a column vector, which is now minus 3, 1, just like that, guys. That is what we have. So from there, I can be able to simplify further. 3 minus minus, take note, guys, minus, and a minus is going to give us a plus. That's 3 plus 3, which is now 6. 4 minus 1, which is going to give us 3. Corresponding elements. So it's now 6, 3. So that is our vector PQ. All right, so that is our vector PQ here. All right. Then we are given if PR is equal to, find the coordinates of R. We are now given another vector, guys, from this part that we had. We are given that there is another vector, which is PR in this case, which is given by 2 minus 6. All right. Then we want to calculate the coordinates of a point. These are coordinates, which means you are writing your answer in terms of x and y like this. Okay. But I want you to note something, guys. If you are to visualize this from what we have been doing before and the questions that you have been answering before, you calculated this vector PR, this one. For you to calculate this vector PR, we know that the formula that was used was PR is equal to, just like what we did on this question. I want you to show you here, just like what you did here. when you wanted to calculate PQ, you said Q minus P, which is OQ minus OP. So which is the same way, which is this R here, which is OR minus what? Minus OP. That was your equation like this. So now if you are to cross check, where did you find this Q and this P here? You took the point Q, the one that you had, which was 3, 4, but you just rewrite it, this one, as a column vector. So that means it's the same thing. If I am given point R in this case, which is given in this case, let's say it's XY, it means vector OR is simply going to be in a column form like that. That is XY. That is what you're going to have. So you're going to obtain your vector OR as a column like this. Definitely your point R, you're going to just write it as the coordinates now. So simply substitute what you're given, because PR is there, that is 2 minus 6 minus OR is the one that we are to find in this case. So I'm just going to leave it like that, or I can write it as XY depending what you want. So I can even write it as XY in this case to represent vector OR, or you can just write it as OR like that. Minus OP. Where is OP? OP is that part that we have from the point P, but we're just rewriting it as what? As a column vector, which is minus 3, 1. So you're going to have minus 3, 1 like that. So this is what you're going to have. So you want to find this value here. So what are you going to do? You transpose. Guys, don't confuse this with what I'm saying. If you could have written this as 2 minus 6 is equal to, in place of XY, you could have written this as OR like this, minus OP, which is minus 3, 1. It's just one and the same thing. This is your OR, this is your OR boss. This is what we have here. So I will transpose this to the other side of the equation, which is going to be a plus. So it's 2 minus 6. The minus, when it gets here, it's now a plus, which is minus 3, 1 like this, which is going to give us XY. So that's what I'm going to be left with. So from this part, collecting your terms, that's 2 plus minus 3, which is minus 1, minus 6 plus 1, which is going to give us minus 5. This is paper 2, guys. You can use your calculator properly. That's your XY here. So if you are to calculate from this side, your answer was going to be like this. OR is equal to minus 1, minus 5, which is the same as this presentation that I'm just saying here. But remember, we said as a vector, yes, it's called XY, but we are not asked to calculate the vector. We're asked to calculate the coordinates of the point R, which is XY. So therefore, our R here now as a point, it's minus 1, minus 5. That is the point R now. From a vector that we have as OR, the point R is going to be just taken as a point like this, not as a vector, but a point XY like this. That is a point, the coordinates. Then this is a vector presentation. So as you can see, so many ways, guys, to attempt these questions. Okay, then the last part, that is on item 3, was to find the equation of line PQ. So as you know, guys, the equation of a line, or that we need, we can write our equation in the form of y is equal to mx plus c, depending with the format that you're going to have. So this is your P and your Q. So all you need is to find the gradient of the equation from our point P minus 3, 1, and our Q, which is 3, 4. So you're going to have x1, y1, x2, y2. So which means our M here, which is our gradient, remember, is given by the formula y2 minus y1 over x2 minus x1. So you can actually substitute our values here. That's y2, which is 4 minus y1, that is 1 over x2, our x2 in this case, that is 3, minus x1, our x1, which is minus 3, like that. All right. So now simplifying further from your calculator, guys, this is going to give you 3 here over, that's minus and minus, which is a plus, and just going to be a 6, which is 1 over 2. And I believe that your calculators, they are giving us the best answers that you are going to have. Is it what you're going to have, guys? 4 minus, which is 3, and this is minus 6 there. All right, so also the issue of working with our points properly is supposed to be we are supposed to be very careful there. All right, so if we are to obtain a gradient of a half, that means our equation is going to be y is equal to half x plus c in this case. Okay, you've substituted because m is the gradient. This is your gradient, which is your m. All right, so that is your m. To find the value of c, just substitute any one of these points that you're given. So you can even substitute this condition, or you can substitute whatever that you have in this case. All right, so I'm just going to take this one. Okay, any point, guys. When y is 4, x is equal to what? X is equal to 3. All right, so that will be half of 3, like this, plus c. And half of 3 simply means 3 over 2. So that will be 4 minus 3 over 2, which is equal to c. So using your calculator, guys, properly, that's actually, or you can just take this concept. This is 1.5, isn't it? 1.5 from 4. So 4 minus 1.5, that is going to be 3.5 in this case, which is simply 7 over 2. So our c is going to be 7 over 2 in this case, if you have to use our calculators properly. So you have got the value of c, the one that we just needed here. So all you need is to substitute this. So it's going to be 1 over 2x plus 7 over 2. That's what you're going to have. So I just want you to cross-check properly, guys, the values and so forth that we obtained there. But I think 4 minus 3 over 2 there, that's what you got, which is 4 minus 3 over 2. That is 5 over 2, not 4. This is 5 over 2 there. All right, so guys, you know, your calculators also simplification and so forth, but just cross check also some of the values that you're going to be having. Like I said, guys, I'm supposed to be having another setup that is going to allow me to put everything there, even the calculators, in a nicer way. But for now, the setup that we have, guys, it allows us to just work it like that. So anyways, from this typical question that we had, that was the equation of line PQ. Also, there are so many formats. You can also use this format to find the equation of a line. Remember, I also told you y minus y1 over x minus x1, which is equal to the gradient. Yeah, so you can even use this one where you're going to find your gradient, which is your gradient. You found it as 1 over 2. Okay, so you can use this, choose any of the points. Okay, any of these points, that will be your y minus y1. So I'm going to choose the first point, y minus y1. Y1 in this case, remember, this is xy, so y1 is 1 over x minus x1. Your x1 in this case is minus 3. This is your x1, which is minus 3, which is equal to the gradient. Remember, it was 1 over 2. So you must obtain the same answer there. All right, so what are we going to have? Minus and minus, this one is a plus, so it's going to be y minus 1 over x plus 3, which is equivalent to 1 over 2. So definitely I can actually cross multiply, or I can just leave this and multiply by x plus 3 both sides here, multiply by x plus 3 both sides. So that means this can cancel, and I'll have something like y minus 1 is equal to half of x plus 3, which is half of x, half of 3 here, which is 3 over 2, isn't it? That's it. Expand by the bracket, then collect our terms, which is going to be half x minus 1 to this side of the equation. That's a plus 1, so it's 3 over 2 plus 1. So we must obtain the same answer just like that one, guys, and that gives us the same answer as what is the plus 5 over 2. So it will be plus 5 over 2 like that. So as you can see, we are obtaining the same answer just like the previous question. Okay, here on this part, okay, maybe I confused someone here. Let me just try and erase that confusion. It's one and the same thing as y minus 1 over x plus 3 is equal to 1 over 2, like cross multiplying. Yes, just one and the same thing. 2 times y here, that's 2y. 2 times minus 1, that's minus 2. All right, which is equal to minus 1 times this x plus 3, which is definitely x plus 3. But if you are to write it in this format, definitely have to transpose to that side the -2, which is going to be a plus on this side, because this is a negative. The moment it crosses the equal sign is now a plus. So that will be +2, which is x, plus 3 plus 2, which is 5. So you can actually leave your equation like that. But if for you to have an equation like this format, so you can leave it answer like that. But if you want to write your answer now, like in the form of y is equal to mx plus c in the gradient intercept format, you just divide by 2 by 2 by 2 each and every term. So y is equal to x over 2 plus 5 over 2. So as you can see, it's simply one and the same thing. So many ways that you can actually use. Okay, let's see what we had on this part. That is on number 3, asked to solve the equation. All right, that is number 4 actually. For A, solve the equation. So here we can okay, there's so many ways again that we can actually do in this case, but I just want you to see this one, which was going to be a much easier way than the expected way. Okay, yes, we could have like combined everything here, make a single fraction, but here there is a 0 here. So can we just transpose this fraction to the other side of the equation so that it can be a positive there? That's 3 over x plus 7, which is equivalent. It's a minus. The moment you take this, it's now a plus. And if you add 0, guys, just like 0 plus 1, that's 1. So 0 plus any number remains as it is. So this 0 plus this part is just going to remain as it is, which is 1 over x plus 2. But now it's a plus on the other side. Why doing this? Because it's easier for us to properly see that here it's just a matter of what? Cross multiplying this denominator, multiply to this side, this one multiplied to that side, just like that. So that means I'm going to have 3 multiplying everything, 3 times x, which is 3x, 3 times 2, which is 6. 3 multiplies everything, it's 1x, so it's 3 times 1x, which is 3x, 3 times 2, which is 6. 1 also multiplies everything, it's 1 times x, which is x. 1 times 7, which is 7. So that's why you end up seeing people, or even me, expressing it like 3 into x plus 2 is equal to 1 into x plus 7. This is why we end up seeing us writing like this. Why? Because we just want you guys to understand that this 3 multiplies everything, this 1 multiplies everything, but we can even do it by side like that. All right, so collect your like terms. X to the other x, that's going to be 3x. The moment it crosses the equal sign, is now minus x, which is equal to 6. Also to the other side is now a minus because it was a plus, so it's 7 minus 6. So from there, what can we do? This is simply 3 minus 1. 3 minus 1, 1x. When there's x there, there's a 1 there. So it's 3 minus 1, which is 2x. Not 3x, but 2x. And 7 minus 6, which is 1. So you can divide by 2 both sides, guys. That's your x, which is 1 over 2. So we have, where are we heading there? We just leave your answer like that. It's in its simplest form like that. So that's fine like that. All right, let me just try and adjust. So you can actually leave your answer in this format just like that. As you can see, these are the typical expressions that you're going to have. All right, let's see another part that we had, which is actually okay. So here I can just take advantage of that. This is another like page, so I can take advantage of this. We have got this question which is on circuit geometry that we are given, and everything is given, and the diagram, the points, these lines being parallel. Take note, guys, B from this one O to P, and this AB, those points, they are parallel. All right, so I'm just gonna maybe adjust using pen so that it can help us see properly what's happening there. All right, so what's the first question actually? Where do we want to apply this pen that we want to apply? Okay, let's see the first question. Calculate ADB. That is the first question, to calculate the angle ADB, and it's actually 1 mark there. All right, so our ADB. So in this case, guys, let's try to do fill-in method, just to fill in values and so forth. Let's try by all means. Okay, our ADB is actually this angle here. All right, and if you were to cross-check, this is an angle that is between what? From this concept here, a tangent and a chord. Remember, angle that is between a tangent and a chord is equal to the angle that is in the opposite. What you do is that you hold this chord. okay, where this chord creates an angle at the circumference. That angle is equal to 28. So this AB creates an angle at D here. It also creates an angle at what? At C here. So which means these two angles, they are equal also. So if this is 28 degrees, this is 28 here, this is 28, guys. So which means this is also 28 degrees. This is also 28 degrees. All right, so we've got 28 degrees there. All right, what else do we have? It's like I said, guys, just a fill-in part that we know that we just want to try here. AOD, this one is the center, so which means AOD is a diameter, and we know that a diameter subtends an angle of 90 degrees at the circumference. So you hold this diameter AD like this to the circumference of the circle. So it helps you a lot just to fill in like that, okay? So AD to the circumference of a circle, that's at what? At B. So this angle at B is what? Is 90 degrees. So you can even write it as 90, or you can just indicate like a right angle like this, or you can even write 90 inside there, okay? So this is your 90 degrees there. And as we know that angles in a triangle, they add up to 180 degrees, so which means we can also have this remaining angle here, this angle, the whole of this angle here, we can have this one. Why? Because we know that these angles are in a triangle. So this 90 here, this 20 here, from 180 degrees. All right, we can find this angle, or we can find this one. So there are so many ways. Also applying your parallel lines. Okay, so there's so many ways that we can actually fill in our diagram. And also this AOB, it's not only creating this AOD here, it's not only creating 90 here, it's also creating 90 here. This AOD is also creating 90 here at what? At C. If you are to cross check here, also at C. So which means also at C here, we've got 90 degrees. So you see, I'm just filling this diagram from the theorems, not from the question that we are being asked, just from the theorems. Also, what do we know? This one, it's a radius, okay? A or the radius, or simply using A or D, we know that when it meets a tangent like this, they meet at what? At 90 degrees. A tangent and the radius or a diameter, they meet at 90 degrees. So this is 90 degrees here. Also, this is 90 degrees. The whole of this angle is what? 90 degrees. So to find this angle here, the one that we have indicated already, this one, or you can simply subtract 90 minus 28, that is this angle that you're going to have. So you see, filling in, it helps you even to attempt every question that follows. Okay, so let's see the first question. Calculate ADB. So as you can see, ADB, let's locate where we've got our ADB. Said ADB already. We have answered this one. We said it's what? 28 degrees. So that's our item 1 in this case, which is ADB. That is a 28 degrees. All right, let's move on. Another one, it's BAP. That's BAP. That's BAP in this case. And BAP, let's see where our BAP is. All right, that's our BAP. This one, I want you to take note, guys, where exactly our BAP is. This is BA here to P here. So you need this angle here that is inside, not this complete one, but this one. Let me indicate, maybe, okay, let me do this way. This is your BAP. This angle here is the one that I want you to see. This one, that's your BAP. This piece alone, this one. So how can we find this? How are you going to find this angle? We are going to use this triangle BAP. So using this triangle, you know that angles in a triangle, they add up to what? To 180 degrees. So to find this BAP, you are going to subtract from what? From 180 degrees using angles in what? Angles in a triangle. That's your BAP. So it means this BAP is going to be this BAP, subtract from 180 degrees all the angles that are inside, which is 90 degrees and this 46 here. So it's 90 degrees plus 46 degrees. Okay, so by doing this, we can find our BAP, which is going to be 44 degrees. Okay, that's P here, BAP. So we're going to obtain 44 degrees. Or we can simply say that since I'm having 90 degrees here, I know that these two angles, they must give me 90 degrees, these two, BAP and the angle at P, because these are angles in a triangle. Like already I have used the 90 degrees, so these two angles must give me 90 degrees. So you can simply say 90 minus 44, 90 minus 46, which is going to give you 44 degrees in this case. So this is your 44 degrees, which is BAP. Take note, this one, this is the one that you're talking about, 44 degrees. All right, so that's our BAP. We said 44. Let's see another one that is on item 3, that is CBD. So it's CBD. Okay, so we need CBD in this case, that is from C here to B to D. This is the angle that you want to calculate, CBD, this one. All right, so that's your CBD, the one that is here. It's not actually part of this 90. It's not actually the one, this one. This is the angle that you're talking about, the CBD, this one. All right, so this angle here that we are talking about is equal to this angle here, which is CAD, this one. They are equal, this angle, this one that I'm taking this way, this one. They are equal, these two angles. All right, so if these two angles are equal, how am I going to determine them? Because if I find one of these, because why am I saying they're equal? They are subtended by what? By the same chord here, the chord of CD, this one, your CD here. So if you are to hold this chord CD, okay, to the circumference of the circle, that's at what? At B. It's the same thing. If you hold this chord again to the circumference, it's gonna give you an angle at what? At A. So these angles, they are equal. Okay, they are subtended by the same chord. So how am I going to find any one of these? Okay, remember I told you about this 90 degrees, guys. When I said this whole angle here is what? Is 90 degrees, this whole angle here. And we know this is 20, and this angle here is 44. So what about this angle here? So it is going to be from 90 degrees. So I'm going to subtract all those angles from 90 degrees. Okay, that's our item 3. So we say this is angle CBD. All right, CBD is equal to angle CAD. Okay, it is equal to angle CAD, which is equal to 90 degrees minus these angles which are inside the triangle, which are creating the 90 degrees, which is 28 and what? 44. So it's 28 degrees plus 44, like that. So that's going to give us 90 degrees minus, you just subtract properly, guys, but this is going to give us 18, because it's going to be 12 here, and it will be 72, and that will be 18 degrees here. All right, so you're going to have an angle of 18. So this angle of 18 is equal to these two angles, so which means here this is 18 degrees here, this is 18 degrees here. So this is 18, this is 18. These two angles, they are equal, they are subtended by the same chord. All right, so that's what you are talking about here. So this is 18 degrees, that's your CAB. All right, another angle was POD. That's POD, angle POD. All right, so let's locate our angle POD here. So that's POD. Okay, POD, that is this angle here. So which concept can we use, guys? POD, that is this angle here. All right, so the POD, you're going to obtain it from the fact that here we are given, remember that we are given that AB is parallel to OB. These lines, they are parallel. So if you extend these lines, it can actually make sense. If you extend this parallel line here like this, you extend this line, you also extend, actually here according to their deck, they just say it's parallel, but according to their sketches, they are not even parallel. Okay, if in fact that is what you have, guys, but let us know that they are parallel. All right, so we want to calculate this angle here, which is POD. So this angle and this angle, guys, let me put it this way. Let me put it this way. It can make sense. I've got something like this. All right. This is what this is the part that I want to explain here. From this point B to A, because these are the lines which are parallel to A here, to O, and to P, and also to D. Okay, so these are the points that I've just taken from the diagram here. B to A, which is this line, BA, P to O, which is this line, O to D, which is this line. So what I want to explain is that this angle here and this angle here, these two, they are equal from what? From your corresponding angles. So which means this angle that we want to calculate and this whole angle, the corresponding angle, take note, is this whole angle of 18 and 44, this one inside the parallel line, this one. So it's 44 and 18, they are equal to this angle here. So that is what? That is your POD in this case. So this was item what? Item 4. So item 4, our POD is going to be 44 degrees plus 18. So this is 44 degrees plus 18 degrees. You just add those two angles, which is going to give us 62 degrees. So that's the concept, guys, that we had on this circle geometry. So you can see it had a lot of things that you're supposed to consider, but that's how they ask these typical questions actually. So I don't know from this platform if there is any part that is not actually visible, but I think I try to indicate in a way that we can maybe understand one or two things from there. Then on number question number 5, we are given the construction. So like I always say, guys, this part I'm just going to redraw the given condition line that we have, because actually there, if I'm to use that part now, because what I've realized is that, guys, okay, let me see if what I've realized is what is happening here. If I'm to measure this line here, this is my AB, this is supposed to be 9 centimeters, and this dent is now, okay, let me just put this way so that I measure properly, because this dent that I'm using is actually, the ruler is too big. Okay, I'm supposed, you see, the 9 centimeters is here, but it's actually greater than, you see, it's actually, so I'm not going to use this one, because I think it's because when you scan these papers, guys, when you scan there, and also when I get the paper here, I try to print and read, so those things actually they affect, I think those are things that are actually affecting. So like I said, I'm just going to redraw there for this line so that it can be clear, not to be like the one that is, because it can affect a lot of things, because we are working with a wrong line in that case. So let us redraw our line in this case, guys. I'm just going to draw just an indication of the line. Remember, you have to mark the 2 points, the ones that you're going to use as your P and your Q. And in this case, I'm going to use this point here to be my reference point. So I'm not going to like have something that is different from the one that was given. I'm just going to work with the one that we had from that presentation. Remember, that is where your P was and your R was in this case. So this is your P, then you just measure 9 centimeters. So in this case, it was already there, but I'm saying because of what, of the things that I was talking about, that it affects a lot when it comes here. So that is what you're going to have now. It affects a lot. So I'm just going to measure the exact 9 centimeters that you're going to have, which is this one. So this is the exact 9 centimeters that I can use from P. So from this point P here to Q, to R, sorry, I'm going to measure my 9 centimeters. All right, so this is R. Also, they cannot give you this always, so you are also supposed to know how to do this also. So this is your PR, which is now 9 centimeters in this case. So already that's our sketch, and on this sketch we are told, or we are given this platform to construct on this diagram a triangle which is referred as PQR with line PR which is being given, and there's PQ. So as you can see from this sketch here, if you are to complete its PR like that, so like it's supposed to be like this, guys. A sketch is like this. This is your P, this is your R, which means this is where you're supposed to have somewhere your Q, because there is an angle 45 degrees between QPR, that is QPR here. There's an angle of what? Of 45 degrees. So you must visualize a sketch like this, where this is your 9 centimeters, your PQ here, which is 7 centimeters. So this is supposed to be your sketch. All right, so here we've got PR, which is there, PQ, but we can't have this line for now because it's in between an angle of a line which has got an angle of 45 degrees. So we need to construct 45 degrees. And where do we obtain this angle 45 degrees? Remember, I told you 45 is from what? 90 degrees. So you have to construct 90 degrees. That is, in this case, it's going to be like this, 90 degrees from P. Remember, 90 degrees, you just mark 2 points from that P. Just mark 2 points with the same distance. Then you open more than half of the line from these 2 points. These ones open more than half, which means more than half, it's just more than this P, just after P from this point, let's say somewhere here. This is more than half actually. Then you mark an arc on top and another one there. But in this case, there's no need for us to use this one because we already have this point P. So just mark on top, okay, because already P is there as our reference point. So you also mark here on top. And also the way I'm holding this is supposed to be like this, guys, okay. Now it's not clear because of the setup, guys, but I think you see what is happening there. So that you join now, and this 90 degrees is not part of our answer, so I'm just going to use this as a broken line. It's just helping us to determine the exact thing. So let us draw this as a broken line, passing that point, joining. Like I said, your reference point is this point at P, so the line is supposed to pass through this point here. It's not even a worry for us, okay. So now let us bisect this angle. How do you bisect? Remember, you want your 45 to be inside. That is the importance of the sketch. Now your triangle is supposed to be inside this side, so you bisect this side, not this side but the right side, okay. So just step it at point P, okay, mark an arc in between, mark an arc on these two lines, okay. The arcs that are creating 90, the lines that are creating 90 degrees, that is this line and this line. These are the lines that are creating what? 90 degrees. Then on those points that you have marked here on these arcs, mark another arc inside where you want to have your what? Your 45 degrees here. And also from this point again, make sure you step on the exact point. Don't confuse your points there. A step on the exact point. All right, so this is going to be just like that. So you have got your these 2 points here, the ones that are on the line that is creating an angle of what? Of 90 degrees. Then from these 2 arcs, you create another pair again from this point that is inside where you want your angle to be inside there. So from this point, you're going to join always where the arcs intersect back to the reference point, which is P. So you're going to join back to P. All right, sorry. So let us join here back to P. Now this is a continuous line because I need, this is where my 45 degrees is. So it's supposed to be a continuous line this time, like that. So let it be big enough also to accommodate 7 centimeters. So you can also indicate this is my 45 degrees is allowed to do this. You can write your 45 degrees, but this one don't write end, because you know this is 45, this is 45. What you would need is this one that is inside your shape. This part is just there to help us, so there's no need for us even to indicate that angle. And also learn to measure each and every angle. Once you are done constructing, measure and see if it is actually giving you the exact angle, just like that, okay. So due to these constructions and also forth, that I'll be using pen here instead of using the exact pens and so forth, but they'll be in line with the angle there. All right, so that's my 45. And what's the other thing that we need from our sketch? We said we need the point Q which is 7 centimeters from P. As long it is on an angle 45, it is 7 centimeters from this point. So let us measure 7 centimeters from the point P to the point Q. All right, so these are centimeters here. So you're just going to measure 7, which is somewhere here. So you just measure properly, guys. So my 7 is somewhere there. That's where we are going to have our 7 from this point here. All right, that's our 7. So that means from this point, I'm going to mark here. That's my 7 centimeters, which is the point Q. All right, like PQR. So definitely, if this is Q and this is R and this is P, we have to join the points so that we can have a completed triangle than to leave our shape like that. Okay, you have to just join the points, the Q and the R. Now you've got a completed triangle. Now this is now a triangle, because remember, we're talking of a plane shape, which is a closed figure. So that's 45 degrees and 9 and 7, something like that. Okay, so on the other part, we are now given to construct the locus of points which are equidistant. Take note, they are equidistant from PQ and PR. Remember, guys, I told you that PQ, PR, this is a line. PQ, PR, a line and a line. So that is angle bisector. You bisect the angle. So take note, locus of points equidistant from two lines. This represents what? Angle bisector. Okay, so you bisect the given angles. That is where this repeats. You just find where it is repeat. It's PQ, from P to Q, P to R. As you can see, it's P that is repeating. So you bisect the angle at what? At P. This one, if you confuse yourself where these two repeat, PQ, PR. Okay, so that's from P to Q, from P to R. This is the angle that is repeating here. So you bisect this 45. All right, so how do we bisect angle? Just like what we did on 90 degrees, we marked on point P. You're going to mark arcs which from the lines which are creating 45 degrees. So this is the line PR and PQ. That is where your arcs are supposed to be, because these are the lines that are creating 45. So you mark an arc on PR and another arc on line PQ, like this. Okay, so using these arcs, I'm going to obtain from these arcs, mark inside the shape, just somewhere there, and also here, just depending with your arcs. Suppose sometimes they can be inside or just that side, but that is what you're going to have. So from these two arcs, guys, I hope so. It said you mark an arc from the what to the lines that are creating the angle. You mark the arcs, then using these same arcs without changing this distance. Okay, you just use the same. You mark arcs inside where you want to have your angle that is on this side. So you mark an arc from the same point you mark, so they will intersect at a certain point. And always I have to join this back to what? To the center, because it's supposed to be at angle P. So I'm going to join where these two arcs meet here back to P, like this. So this is what I'm going to have, just like this. Okay, so by bisecting this, I have divided this angle into two equal parts. So what you do, guys, is just bisect all these concepts they are going to mark, and no, so don't indicate anything, just bisect your angle like that. You are done. All right, then another point is the locus of points which are equidistant from P and R. P and R, that is, P is a point, R is a point. Remember this one, guys, I told you that's a line bisector, because they form P and R, they form a line. So this one is a line bisector. So you bisect the line PR. It's going to form a line PR, that is from P to R. Here you bisect that line. Okay, so how do you bisect a line? So all these concepts from where, how to bisect a line, how to bisect an angle, I talked about them from different from separate topics. So make sure that you watch the video so that you can be able to understand. So I'm going to bisect a line where I told you guys you just need to open more than half of the line, like this, just more than half. Then you mark an arc on top, another arc below here. All right, so you mark an arc on top, another mark below. Okay, then from P you do the same thing again. You mark an arc on top, another mark down here below. So where these two meet at this point, as you can see, the arcs, they meet at this point, and this arcs here meet at this point. That is where you join. So by joining that, you have bisected, or you have divided this line into two equal parts, that is to bisect, which is also called a perpendicular bisector of the given line. Hey guys, here I didn't join properly. Make sure that you join properly. So make sure also your lines, they're big enough to just accommodate maybe at least 3, 4, 5 centimeters there. So that is what you're going to have. So if you measure from this point to this point and this point, this line is going to be two equal parts. So that is a line bisector. All right. Another part we are now given to mark and label clearly. So you have to mark, then you label clearly the point X, which is equidistant from PQ and PR. Take note, PQ and PR, this one, we obtained angle bisector, which means we are talking of this angle bisector here, okay, and is also equidistant from P and R. P and R, that was our line bisector. So where these two loci mean, which means there are now two, that's loci there. So where these two meet, that is where you have your point. So you mark that point and then label it X. So this is our point X. All right, so I've marked the point and indicated X. Then measure and write down the length XR. So you now measure your length XR. So what you just do is that you put a divider from X to R there, from X here to R on your divider, just like this. You just use your divider here from X to R, that is your R here. All right, so this is XR like this. Okay, so with this distance that you have on your divider, this distance is the one that you're going to use now to measure the exact distance on your ruler, or you can just place a ruler at once. It's just one and the same thing. So here we've got those millimeters and so forth. So it's going to be somewhere here, which is going to be 4, because this is 4,5, because this is 40 here, so it's 40 millimeters, which is 4, so it's going to be around 5 there, which is 4,8. So all you need is to measure properly, guys, that distance, or you can just place your ruler there direct there. Then PRQ, okay, PRQ, that is the angle now, this one, PRQ. So how do you measure the angle? I told you guys that you put this your protractor. Now this one is not clear. I don't know if it is clear enough, but this is what you put your protractor here, and this point here, this needle point, is supposed to be on R, the angle that is you are measuring, because you want to measure this angle R here. So this must be on R, the plus here, depending with the type of what protractor that you're using, but this where these two meet the plus here. So you place it at point R, and this line also, the other thing, this line here that is on your protractor, this line, it covers up like this line PR, this line, it covers up like that. So you're going to be able to line like this. All right, so this is what I'm gonna have here at this point. Okay, so this is the angle that I want to measure. So this is PRQ. So I'm measuring the angle that is inside the triangle, not this one. So I'm measuring this angle here. So as you can cross check, it's 0 here, 10, 20, 30, 40, 50. This angle is at 50 there. All right, yeah, that is at 50 there. So this is the angle that I'm measuring here from this point going this direction, not this way. This 130 is from the one who is measuring this angle outside 0, 10. As you can see, they increase this way. You are taking angles which are increasing in this way because you want this angle that is inside the triangle. So your angle is going to be 40 degrees there. So this is 50 degrees, sorry. That is the angle that you're going to have. So it depends with what you're obtaining from here there, but here we obtained 50 degrees. So you don't write it here. I'm just indicating. You don't write it inside. This is another item that is separate. So you write on your item there the angle that you have obtained is we said 50 degrees. All right. So you're going to write it in your answer book, whatever that you're going to be given. Maybe you're answering on the question paper there, or you're given the answer book, or you're given papers to write on, to answer on. That is what you're going to have, but that's the concept that you've got here, guys. Okay, so These are the typical questions that actually they are giving you on constructions and so forth. So you're supposed to be very, very careful enough. Okay, got this one on number 6A now, which is you're given a diagram there, which is a right angle triangle actually that you're given, and you're asked to formulate an equation which is going to reduce to that particular one that you're given. So how are we going to formulate an equation? It's actually a completed triangle. Everything is complete, and it's a right angle triangle. So let us just try to play around our Pythagoras theorem then. Since we know that if this is A and this is B and this is C, we know that C squared is equal to A squared plus C from our Pythagoras theorem. So let us just try to play around that. Okay, let us try to play around our Pythagoras theorem. So if C squared is equal to A squared plus B squared, where we are simply talking of the hypotenuse in this case, the hypotenuse in this case, which is x plus what? Which is x plus 2. So I'm simply saying x plus 2 square, that is your hypotenuse, equals go to the shorter sides, which is A and B, which is x and x minus 7. So we shall have x squared plus x minus 7 squared. Okay, so we formulated an equation that we need to at least simplify further. Remember, x plus 2, you're simply referring to two brackets, guys. Okay, you can just have these two brackets, x plus 2 into x plus 2, which is equivalent to x squared plus, we've got two brackets here, x minus 7, or you can use identities, guys, x minus 7. Okay, that's x and x, x squared, x and x, which is 2x, 2 and x here, which is 2x, 2 and 2 here, which is gonna give us a 4. And on the other side, we still have our x squared, which is going to give us here, we combine x and x, that's x squared, x and minus 7, minus 7x, minus 7 and x, minus 7x, minus 7 and minus 7, which is what? Plus 49. Take note, we said x here, then x here, which is minus 7x, then minus 7 and minus 7, which is 49. So collect like terms, 2x plus 2x, that's 4x. So we're going to have x squared plus 4x plus 4, which is equal to, here I've got x squared plus x squared, which is 1 plus 1, that is going to give us 2x squared, minus 7 minus 7, which is minus 14x from your calculator. Remember, this is paper 2, guys. Use also your calculators, guys. All right, so what am I going to do in this case? Since I have simplified this, let me take this part here and refer all these terms to this side of the equation. So I'm going to start by writing this part, which is 2x squared minus 14x plus 49 in this case. So if I transpose this x squared, go in here so that it can be subtracted, the 4x to this side, it can be subtracted also, the 4x to this side, it can be subtracted because it has crossed the equal sign, and this side will remain with nothing, that is now is remaining with a 0. All right, so now the 2x squared and the minus 1 here, because this one is x squared, so it's 2 minus 1, which is 1x squared. But writing 1x squared, guys, is same as x squared. Okay, I see most of you guys writing 1x. 1x is same as x. Okay, let's move on to x here. It's minus 14x and minus 4, that is minus 16. So it's gonna be minus 18, not minus 16. We've got minus 2x, guys. All right. So let us just cross check where we got it is minus 18. Okay, this is minus 18, which is we are fine here. Minus 14 minus 4, which is minus 18, isn't it? Yeah, that's minus x. Yeah, it's 14 here, it's 4. Okay, so it's fine here. Minus 14 minus 4 from a calculator, that's minus 18. Then 49 minus 4, which is 45. Okay, which is equal to 0. Is there everything fine? Yeah, everything is fine. Then you cross check your answer, if truly that is what you are being asked to reduce up to. That is you just cross check your answer there and simplify further if that is the exact thing that you are given. All right, then now you are given that is actually where it ended, because yes, just to show that, as you can see, that's it. Then to solve the equation now on item 2. So whether maybe you failed to reduce up to this format, you failed to do that, but this question is just another question. Yes, this equation you have to show, but this one you cannot say, since I didn't manage, you now start solving with that equation that you had. No, you use this one that you already have, which you are given on item 2, not the one that you calculated. Maybe you got a wrong answer. Just work with the one that they gave you here, which is 45 is equal to 0. So definitely it's working with a quadratic equation if possible. If factorization is not exact, so you just try. It's a matter of trial and error, guys. It's not like we have got something that is exact. 45 and x squared is going to give us 45x squared. So we have to try factorization. If they are factors, they're in between. So to have factors, if we've got 15, if we are talking of 15 and 3, there's something that connects with 18. But yes, we've got minus 18. So this, let's try working with minus 15 and minus 3, because we need also positive 45 if we multiply this. So we've got minus 15 and minus 3. So these are the possible values that we can actually have. So in this case, remember the equivalent of x squared is 1. So I can just have two brackets, x minus 15 and another bracket, x minus 3, being equated to 0 there. So x is equivalent to minus 15 to the other side, that's going to be a plus, or x minus 3 to that side is going to be a plus 3. So as you can see, these are the possible values that you are having of x, which is going to give us 15 or a 3 there. So that's it. Then the length of AP, we're asked now to calculate or to write down the length of AP. So this is your AP here, which is x minus 7. So our AP is actually x minus 7. All right, which is x minus 7. So you're going to take the x here, but as you can see, we can't use this one because 3 minus 7, it's impossible. That's minus 3. So you can't have a length like that. So you're going to use x being minus 15. So it's 15 minus 7, which is going to give us something like 8, if we are to simplify properly in that case. So that is how these questions are presented sometimes. So just have to be very, very careful how you attempt this question, but that's what you had. So you just cross-check there, guys. If you add anything that is not like exactly what we have there, but that's what you had. And also this question here is actually like I don't know how it's, because this is not exactly like exact the values that the way they are presented here. So I don't know what am I going to do for now, because these values, they're not even corresponding well here. So what I'm going to have is, if I can have another copy, maybe to work it on the exact copy, like where it's supposed to be, because like these values, yes, some of them they correspond, because this one is like it's 5 here, and this one is 15, it's fine, and this one is at 1. But as we know, guys, for you to write the inequalities, all you need is to have your equations first. Then the issue of shading, it's all about the lesser region and the bigger region and so forth. I think I explained this in a much way on inequalities. You can even understand much better. So you can just cross check, but I'm going to come with it and work on this one separately, because it seems like there are some values which are not even exactly presented there. So I don't want something that we work on it, then we come back and say this was like this, like that. Okay. On number 7, we are given that is a solid, that we are given on solid shapes there, where we have got a diagram which shows a trophy in the form of a prism whose cross section is ABCD, which is a trapezium. So this cross section here, ABCD, which is a trapezium. So a cross section simply means what you see here is the same thing that you see on the other side here, which is PQRS. That is another cross section. So that's the cross sectional area times the distance of this. You now have the volume of the whole shape. Okay, so the question is to calculate the area of the cross section ABCD of the trophy, which is the trapezium. So they are simply saying calculate the area of a trapezium, and we know that the area of a trapezium is equivalent to the sum of half the sum of the parallel sides times the perpendicular height. That is your cross section. Your cross section in this case is a trapezium, and this is what you want to calculate. ABCD, ABCD, a trapezium. So the parallel sides, that's 21, and 40. These are the sides which do not meet, and this is your perpendicular height. So it's going to be half of 21 plus 40 in this case. These are the parallel sides times the height of 14. That is 14. So all you need, guys, is to use your calculator properly there and so forth, which is half of this, which is 7. So if we add, we're going to have 61 times 7, which is 427. These are meters, or the measurements are in centimeters, so which means your area is going to be square centimeters. Remember, this is area, square centimeters. All right. And on the other part now, which is the B part, we're asked to calculate the number of liters needed. Oh no, this is the B. We are still on A. This is just A, B, or all right. Calculate the number. This is, we need item 2 of this one, guys. All right. So all right, it's here on the item 2. I was wondering, where is this question now? Item 2, calculate the capacity of the trophy when full. So capacity, that's volume. All right, the volume when it is full. So remember, I told you guys, when you are given a condition where you have got a cross section like this, where the cross section that you see on this side is the same as the cross section that you see on the other side like that, the volume is equivalent to the area times the height. When I say height, I'm referring to the distance from one cross section to the other cross section. So in this case, we have already calculated the area. So our volume is going to be area times the height. Whenever you have that in, this is one of the cross sections, so it's area of this cross section times the height to another cross section. These two, they are separated by what? By 90 centimeters. So we are going to simply take the area that we calculated, which is 427 square centimeters, times the height of 90 centimeters. In this case, that's gonna be something like 38,430. This, which is in cubic centimeters. This is now volume, cubic centimeters. All right. So that's what you simply had there. Then the inside trough is to be painted. 1 liter of paint covers an area of 1,469 square centimeters. Calculate the area of the trough to be painted. Okay, this is a trophy that we are talking about. So the first item on item 2, which is B, item 1 is just to calculate the area that is to be painted. So a trophy is always open. This is a trough, so it's open on top here. So definitely the area to be painted is this side, because this trapezium is inside the trough. So you're going to paint the inside and the inside, that is 2 trapezia, because you've got 2. So they are now 2 trapezia. So you multiply the area of 1 trapezium times 2. Okay, because they are now 2, and we obtain the area of a trapezium. Before that is the one that we calculated the area of the cross section, which was 427 square centimeters. So we said area of a trapezium times 2. Okay, so you're going to have 420. So let us calculate the total area. Okay, so you said area of a trapezium 427 times 2 plus, okay, what do we have? I want you to see here on the base here, there's a rectangle. Sorry, on the base there's a rectangle of BC to CR here. Okay, BC, CR, RQ, and QB. We are formulating a rectangle down there. So that's a rectangle which is 21 times, suppose definitely it's a trough, so you paint the down part, that one. So it's 90 times 21. Okay, 21 times 90 plus, this is only 1. Okay, this rectangle here of 18 here, we've got 18 and 90. This side view, definitely you paint this one, which is the same as this one, also 18 times 9. So there are 2 of them, this one of 18 and 90. So you've got 18 times 90, which is a rectangle, but there are 2 of them, so you multiply by 2. And the top part, it's open. This one is a trough. You know that a trough is open on top here, so there's nothing that you're going to have shaded here. We are painting inside, so the top is open, so you just leave it like that. So that's how you work out these questions. So definitely this will be the area that was needed in this case to be painted, which is going to give us 854 plus 1890 plus 3340. If we multiply properly, that's going to be 59,000, not 59,000 but 5,884 square centimeters. That is the total area that was needed. Okay, so the question is to calculate the area of the trough to be painted. That is the total area that we are talking about. But we are told that 1 liter is going to cover 1496. So this is a statement that is separate, but it's under B. That is why we see that statement now to be used on B item 2, where now they are saying calculate the number of liters of paint needed to paint the inside of the trough to the nearest liter. So where am I going to have the total number of liters? I'm going to start from this way, where I'm being told that a liter covers 1400 and so this is actually B item 2. I have a liter covering 1496 square centimeters. So what about the total area that was to be painted, which is the total area, the one that we just calculated now? So I'm going to substitute now to say for this area, which is our total area of 5,984 square centimeters, how many liters am I going to have, which is more? So it's 5984 over 1496 times a liter in this case. So this is going to give us a direct answer, which is 4 liters in this case. So we need 4 liters to paint that trough. And the cost of paint, if it costs $6 per 1 liter, 1 liter costs $6.30. So how many are we going to need? Definitely we just need to multiply here, all right, because 1 liter is going to cost you $6.30, and you've got 4 liters in this case. So using simple proportion, you're just going to multiply 4 over 1, that because this is more, so it's 4 over 1 times $6.30. That is the amount there, which is going to give us $25.20 if you multiply properly there. So this is paper 2, guys. Your calculator also with you. You must supposed to understand each other, you and your calculator, very much, because that can be a good relationship that you and your calculator can have in paper 2, because you need that relationship. Anyways, we are given on question number 8 a table. The table shows the results of 40 candidates marks in a physics examination that we are given, the mark, the frequencies, and we are given to calculate the value of m. So definitely we've got 40 candidates. So to have the value of m, we are going to subtract all those frequencies that we have from what? From 40. So that is, you have to add everything in that case. So your 8, that is 8 item 1, 8a item 1. So our m is going to be the total number of candidates, which is 40. All right, that is 40 in this case, minus the sum. You add everything in this case. So if you add everything, you're going to obtain 38 there, so which is going to give us 2. So which means m is equal to 2 here. There is a 2 here on m. All right, calculate the approximate mean mark of these candidates correct to the nearest whole number, guys. Remember, issue of mean mark, guys, you have to calculate the class center. So it's actually the class center that you have of the students. So as you can see, this is a 0 here. If you're going to multiply by 0, so not wasting much time, you just leave it like that. But your class center, remember, you add lower class plus upper class, then divide by 2. So if you add 40 plus 45, then divide by 2, you're going to obtain what? 42,5. Then you multiply by the frequency here. So that is your, like, the working that you're going to have. So we said 42,5, which is our value from the mark, then times the frequency of 3. So you multiply to the frequency. You move on to another class, 45 to 50. So if you add these two, divide by 2, that's going to be 47,5 times 7 times 7. So you keep on doing this until the last part, guys. You move on to 50 up to 55. You divide 50 plus 55 divided by 2, that's 52,5 times the frequency of 12 there. That's on 52,5. You move on to another one, which is 57 now. So it's going to be 57,5 times 9 You move on to this one of 60, that would be 62,5 times 5, 62,5 times 5, and so on. So that's what you're going to do until the last part. 65 to 70, that's going to be 67,5 times m, and m is the one that we obtained there, which was 2. So you multiply by 2 plus 70 to 70, which is 72,5. So it's going to be 72,5 times 1 until you obtain the last one, guys. 77,5 times 1, everything over the total frequency of you're given. These are 40 candidates, so all you need is to combine the one on top, which is going to give us 2205 over 40. So dividing this is going to be 55,125. All right, and you're given to the nearest whole number, that is the whole number that you have is 55, and this number is actually less than 500, so it cannot change. This one is less than 5, so it's just going to be 55. So that is what you're going to have in this case. All right, then we are given that there is a table that is shows the cumulative frequencies that we have. So remember, find the value of n. Remember, cumulative frequency, you are adding from the first frequency that you have got, which is 0 here, 0 plus 3, which is 3 here. Then you move on 3 plus 7, which is going to give us 10 here. Then it's 10 plus 12, which is going to give us here. So which means this n is simply 10 plus 12, which is going to give us 22. So that is what you do this until the last part. All right, so that is your cumulative frequency. Remember, use the cumulative frequency table if you are to draw the cumulative frequency graph or the ogive. That's where you apply the cumulative frequencies that you're given. So in this case, that's what you had. And let's see the other part that follows. Okay, the other part that follows, now we are actually given the graphical presentation in this case. So I'm just going to take away this one. That is why that you are given. Actually, maybe it's not clear one of there, but here we are already given like the graph and so forth. Okay, so in this case, I'm just going to take it here. I'm just going to use this part. Okay, so maybe it's just one and the same thing. Actually, just took like what it was. So that is what you're going to have here. So what you need is to analyze also that each and every box, how is it represented? How do you read out the values, the scale, and so forth? So this is 10 representing 10, 10, 10, 10, and also 10 here. So which means each box represents 1, 1, 1, 1, something like that. Okay, so all you need is to mark your points here. The first point, these are the upper classes. Remember, when you draw your cumulative frequency, you need upper classes. So as you can see, 40, 45, 50, these are upper classes. 40, 45, 50, 55, 60, these are the upper classes. So they have already given you the upper classes versus the frequency, the cumulative frequency. So that's what you need. 40 versus 0 here. That's 40 and 0. You mark your point. That is the first point. That's 45 and 3. So remember, we said each box represents 1. So it's going to be 45, which is 41, 42, 43, 44, 45 in between. Then 1, 2, 3. You mark your point. So each box represent, count it as 1. Okay, that's 50 versus 10. This is 50 versus 10. You mark your point. That's a cumulative frequency. 50 and 10. That's 55 and 22. So 55 in between. 50 and 60, that's 55 and 20. So just come here, that's your 50 here. So 51, 52, 53, 54, 55 versus 22. So you said 55 versus 22. This is 20, 21, 22. So each box represents 1. So you mark all these points properly. 60 and 31, that's 60, 31 somewhere here after 30. Okay, another one is 65 versus 36. So it's 65 in between 60 and, okay, and that will be 65, but it's now at 36, so you just target 30 here. So 36 in between 1, 2, 3, 4, 5, that would be 65. So we need 36, which is 31, 32, 33, 34, 35, 36. So which means actually you're referring like 4 boxes before this. 1, 2, 3, 4. Yeah, that's something like that. So you've got 70 here versus 38. So this is 70 here, 38, which is 2 boxes before 40 here. So you can just calculate 2 boxes before 40. That is your 38. All right. Then 75 versus 39. So 75 in between 70 and 80, but 1 box before. So you just count 1 box, 1, 2, 3, 4, 5. That's your 75 here. And 1 box before what? Before this 40 here. Okay, then 80 versus 40. This is 80 versus 40 here, which is the last point there at 40. So that's 80 versus 40, like that. Okay, so these are the points that you have got, and you must draw a smooth ogive. Make sure that your end is inside the curve for you to have a smooth ogive. So starting from this point, so I can just have my point like this, very, very smooth, guys. Just join these points. You can have, or you can create a smooth ogive like that. Okay, so I'm gonna take this part here on this side, rotate this. So remember, I want to join from this so that I can have it a curvy part like that one. Okay, guys, so you are supposed to do much better than normal. So it's because of using pen and so forth, but that's what it's supposed to look like. And now you have got this part here, very, very smooth and curvy. Okay, so it must be a smooth curve, not cross and so forth. So your curve is just like this. So that's your cumulative frequency, which is sometimes referred to as the ogive. So it's the ogive, the cumulative frequency, just one and the same thing. So that's what you had. And the other questions actually which follows, those questions are supposed to be on your graph, like to determine the median mark. Remember, median is half of the total distribution. These are the marks here. These are the marks here. So you find half of the total distribution, which is half of 40 plus 1. So your total distribution is 40. So you find half of 40 plus 1 like this. Half. Okay. That's half of 40 plus 1 in this case, which is going to be the total distribution. Like we are saying, half of n plus 1, that is the median. So the n is the total value, the total frequency here, which is what? Which is 40. So it's going to be 41. So half of 41, guys, which is something like 20.5. That's what you're going to have. That is 41. You divide by 2, which is going to be 20.5. So at this value, this is not your median. No, this is one that you're going to use now to calculate your median. So you're going to locate this point from your cumulative frequency, your 20.5. Remember, we said this is actually representing 1. So you need 20.5. It's in between. It's half a box actually, because this is actually 21 here. So 20.5 is in between. So you just draw a line back to the what? Back to the your ogive, which is back to your cumulative frequency there at that point, which is approximately in between this point, back to the what? Back to the ogive there. So where this meet with ogive, that's where you're going to take, which is your cumulative frequency. That's where you take the value to the marks here, because you're talking of the median mark. So in this case, you're going to draw or to represent with a broken line, or you can just draw back to that line, guys. I don't know if it is going to be exactly this thing, but that's how you take your values there. So you take it back. So here in between, yeah, just take a value that is in between there. According to my graph, it's 1, 2, 3, 4,5. So it's going to be 54,5. That's what I'm having. According to my graph, is 54,5, which is, if it is percentage, then you write it as a percentage. But if it's just a mark like there, okay, this is marked as a percentage, so which means you're going to put it as a percentage. So it's going to be 54.4%. So this is your answer to the item that here that you are going to write here, which is your 54. So like I said, you write the answer that you have from your graph. It's actually an estimate that you're doing. Okay, then the number of candidates who passed examination, if the pass was 49%, the pass mark was 49%. We are using the graph, remember. So those who passed, for you to pass a test, you are being considered to have 49%. So how many passed the test? Okay, so this time you're going to refer from the marks back to the number of people to say at 49%, this is at 49 because this is 50, so 49%, you refer from marks now back to the number of people, just to the cumulative frequency, which is opposite now. So back here, you are going to obtain a corresponding value, guys. I'm just going to use this one, a visible value here, because remember, this graph, we drew it out of our hand, so it's not going to be like that exactly. So this is at 49%. The corresponding number here is the one that you're going to take, okay? But we are told that those two parts, which means these ones who are below this one at 49 at this stage, we're talking of these people who didn't make it below. So we are going to subtract now to the total, which is the final mark that we have got in this case, which is according to our distribution, it ended at 80%. We did not have any weird 100%, so we end according to our distribution, which is at what? Which is at 80. And at 80, it was corresponding with what? With the 40, a total of all of them. So you're going to subtract the difference between the two there. Now your answer is from the cumulative frequency, from the marks to the cumulative frequency now. So you are obtaining your answers from the cumulative frequency this time. Sorry, not this one, but this one here. So you subtract 40 minus this value here, which is somewhere at 8. All right, somewhere 7 there. All right, so like I said, it depends with your value, that is your curve, how smooth your curve is, but that is the case. So you're going to subtract. So according to me, in this case, I was going to subtract 40 minus this value, which is 7, so which means I'm going to have 33 students who passed the test. So depending with what you're having there, but that was the case. All right, for number 9, we are then given a right pyramid, which is on a rectangular base. So this one is different from those topics, from those part where we have got a cross section, like what you see here on the base is not the one that we see on the vertex here, but this piece here and this piece are the same, or this view here on this side and other view on the other side, they are the same. Okay, anyways, the question was to calculate the length of the diagonal AC. That is the diagonal. Take note, this is A, B, C, D. We are given that as a rectangle, so it means the O, which is the center of the rectangle, there is equal distance. We can just have a construction. Is it going to make sense? Now you see now the diagram in this part, these people, they're just doing not even according to exact things. You see now they're just drawing, but supposed to be to exactly thing what they have said there. All right, anyways, this is how it is supposed to look like. Okay, this is actually a diagonal here, so these two, they are going to meet at the point O, which is the center, and we are told that this is going to be perpendicular to that side. Okay, anyways, how can we find the length AC? In this case, for us to have AC, we can use this part because this is a right angled. This is a rectangle. You know that each and every angle is 90 degrees, and this AC is in a right angle triangle, and that is your hypotenuse, which is the longest side, the one that is opposite to this 90 degrees. Or this one, you can use this as your 90 degrees, because when this is 7, this is also 7. When this is 24, this is also 24. So you can use your Pythagoras theorem to find that AC. Since we know that okay, so I can just even put it here. C squared is equal to A squared plus B squared. So our C squared, that is your hypotenuse, which is AC squared, that's 7 squared and 24 squared. So that's AC squared is equal to 49 plus 24 squared, which is going to give us 576. So if I add these two from my calculator, that's 625, which is AC squared. So to find AC, simply put the square root. So AC is going to be square root of 625, which is 25 centimeters. So that's what we have, guys. From A to C, we have got 25 centimeters in this case. So that means we have got a difference, because this is the center here. So if this is 25, it means from this point O to A is going to be 12,5. From this point O to C is going to be 12,5. Remember, this is the center, so it is going to divide here 12,5, so that it can give us 25, the whole of it. But in this case, we are answering AC. I'm just explaining to say maybe it can help us somehow. We don't know. We do not know what's going to happen there. Okay, on item 2, we have got now you see the length of VA, the edge VA. This is the length of this edge VA, this one VA. So as you can see, we need this AO and this VO, because this is forming a right angle triangle. If you have to see, this is a right angle triangle here, and we say this is the center. So if this is 12,5, this is 12,5. So I'm going to use this triangle with the 30 here and 12,5. Okay, so still Pythagoras theorem again. All right, still on our Pythagoras, which is going to be item 2 in this case. So now it's a VA squared or AV squared, but just write as you are given. VA squared, which is the size, which is 30 and 12,5. So it's 30 squared plus 12,5 squared. All right, so that will be the case this time. So our VA squared is going to be, if you combine these two, it's going to be 1056,25. Then now the square root both sides, so that's your VA, which is going to be 32,5 centimeters in this case. So this is our V to A, which is this VA, this side here, this one that you're talking about, which is 32,5 centimeters. That's your VA. So as you can see, we use this triangle, which is the same thing here, this from V to O to C, which is the same as your VC, this one, which is the same also as 32,5 centimeters. So you see there are so many things that you actually have got there. All right, anyways, let's see another part now that we are asked to calculate now, which is to calculate the angle at which VA makes with the horizontal plane ABCD, the angle at which this VA makes with the angle, okay, with the horizontal VA. Okay, this is the VA that we just calculated, this one, and it makes an angle with the horizontal at this point here, because this is your horizontal of the plane, this one, at this angle here. That is where it makes an angle. So you need to calculate this angle, which is VAO, or it's VAOC. So you can even put it as theta, just like that. So as you can see, guys, it's a right angle triangle, so you can play around with the trig ratios. I don't know which one are you going to use, because you've got everything. You can use any ratio, because here, according to this theta, we have got opposite, we have got adjacent, which is this AO is adjacent, we have got the hypotenuse, so everything is there. So in this case, I'm going to just choose for sine, where sine I know is opposite of hypotenuse. Okay, that's my sine theta in this case is equivalent to opposite, which is 30 over the hypotenuse, which is the one that I just calculated now, 32,5. So that's it, guys. To find theta, remember, we're going to write this as arc sine, like this, 30 over 32,5. That is arc sine, shift sine, or second function sine, shift sine, like that. Okay, that will be your arc sine, which is the angle, which is going to give us 67,380, something like that. Okay, so that's our angle. Normal angle, remember, to 1 decimal place. So to 1 decimal place, that's 67,4. That's why I always say read the instructions that are given on your question paper there. All right, which are very, very important. The instruction that you be given is very, very important. Also, when it comes to the rounding off, but the degree of accuracy there is supposed to be very, very important. Okay, anyways, let's see on number B. There is a work. Works means weekly income is made up of a fixed weekly wage and an overtime wage. All right, so they've got a lot of things, but you're not given the letters to use. So let us just choose letters to work on, or letters to use in this case. Okay, a work means weekly income. So let's just say the weekly income, that's our W in this case. Okay, weekly income let's say that's our W, is made up of fixed weekly wage. Okay, there is a weekly wage. In this case, let's just say weekly wage, that's our X, all right? And an overtime wage, there's an overtime wage. Overtime wage, which is Y. Let's just say it's Y. Okay, so I'm just choosing letters because we're not given letters to use, so at least we can understand what this represents. Okay, so the weekly wage, which is our W, is made up of this at which the number of hours, that is the income. If the, so which means this is actually a partial variation that we are talking about, where the weekly wage is like it's partly constant, because when it is made up of a fixed weekly, this is a fixed weekly wage, which is X, so it's a constant that is fixed. That is our H, or we can just write as X in as Y, or whatever that you want to choose to be your constant. You can choose it to be H or to be Y. Okay, but here we are given that, and the overtime wage, which varies directly as the number of hours, which means we've got the number of hours, which is time in hours. So you can say our time in hours be T. In this case, let T be the time in hours. So the overtime wage has to correspond with the time in hours, so you multiply these two like that. So W, which is the weekly income, is equal to the fixed weekly wage plus the overtime times the number of times that is going to happen here. So that's what we are given in this case. All right, the first part, if he works 6 hours overtime, his weekly income is, so we are given the weekly income of 96, which is our W, which is the weekly income 96, when the overtime is 6 hours. So you're going to have X plus the time, which is 6 hours times Y, because this, we do not know this value. And when you move on here, if he works 8 hours, his weekly income is 103. So the weekly income is the one that you are given, 103, and the time is 8 hours, which means we are given T. So it's going to be X plus 8Y like this. So you formulated an equation like this. So from this equation, we want to find the worksman fixed weekly wage. Answer the question, guys. We want to calculate the fixed weekly wage. And our fixed weekly wage in this case is this value here, that is X. So simply the question is saying calculate the value of X. We are not calculating any other value but X. So just focus with X in this case. So how can we calculate the value of X? Do we have to find the value of Y then and so forth? Yes, you can do that, but since I just want to calculate X, I can simply eliminate Y in this case because I want to calculate X. So eliminate what? Eliminate Y. So how can I eliminate Y? Interchange this, because this is 8Y, this is 6Y, 8Y. So I'm going to multiply by 8 on top, by 6 below there. So by 8, everything changed. 96 times 8, which is 768, is equal to 8X, 8 times X, 8 times 6, which is 48Y in this case. Okay, the second equation by 6 by 103, which is 618. 6 by X, which is 6X here, then 6 and which is 48Y like that. So this is a plus here. So since we want to eliminate Y, because the moment we remove Y, we are going to be left with X, and X is the one that represents the fixed weekly wage. So by calculating X, we are calculating the what? The fixed weekly wage. Okay, so we can subtract this, which is going to give us 150 here to eliminate this Y. So it's 8 minus 6, which is 2X. So divide by 2 by 2, our X is going to be 75. So this is our fixed weekly wage, which is F75 plus, which means when there is just a wage is something that is we are saying from the, because here we are given some like another amount that you are going to get after the number of hours and so, but a fixed, which means without any overtime, without anything, that is what this guy was getting, of $75. That is the value of X. Or yes, you could have just solved for X and to solve like you're solving a simultaneous solve for y, then you calculate the value of x. What is important is the actual answer that is going to represent the week's the workman's fixed weekly wage. In this case, that is the one that matters, the final answer. The way that you're going to do or to have this answer is another way, but what is our answer there? That is what is important. All right, so let's see another part on number 10. Actually, we are given, let's say, quadratic the equation of a quadratic, and then we are given the table, then to find the value of p. So to find the value of p, you simply substitute -3 into the equation, guys. As we know, it's just a matter of substitution there, where y is equal to 5 minus 3 into px, which is -3, okay, then -2 into x, which is -3, so it's -3 squared. So you can simplify this even with your calculator direct. Y is going to be -4, so that is the value of p, which is -4 here. All right, then now we are asked to use the grid there to draw this graph from this grid that we are given, and that was the grid. And as you can see, guys, it's not clear enough, like to have what I actually wanted here. So I'm just going to use this grid here, all right, to obtain at least what we have there. So what you simply need is to also understand your scale. This is 10 boxes representing 5, which means each and every box has 0.5. Here 10 boxes representing 1, which means each box is 0.1. all right, -3 and -4. X is -3, y is -4. So x is -3 here, y is -4. So guys, what about 1? What does 1 represent? Actually, 1 is represented by 2 boxes here. 2 boxes, they represent 1. That's 1. Like here, I've got 1, 2 boxes, 2, 3, 4, 5. So 1 is represented by 2 boxes. So which means -4 is slightly 2 boxes before -5 here. That's 1, 2 going back here. That's your -3, -4. So you're supposed to take 2 boxes represent 1. So if this is -5, therefore 2 boxes below before that. Okay, then -2, -3. All right, -2, -3. So you just calculate 6 boxes that will be at -3. That's 1, 2, 3, 4, 5, 6. Just calculate 6 boxes. All right, that's your -3, because this is -4, -5. All right, then -1 versus 6. This is a positive, guys. Is it a positive or negative? Okay, let's just cross check the other values here. Properly there at -5, because this is 5, -3, that's 3 times -3, guys. That's -3 -2 into -3 squared. Let me just cross check something here. Okay, that's a -4, exactly. That's a -4. Okay, this is -1 and -2 and 3, not -2 and 3. Why, guys? You see this thing of being tired now, what it causes. This is a 3 positive there, so you're going to count 6 boxes going up. 1, 2, 3, 4, 5, 6. Somewhere here, mark your point properly there. All right, then -1 and 6. That's -1 and 6 above 5. Just count 2 boxes again. 1, 2. That's your +6 there. Then you've got 0, 5. Okay, that's 0 and 5 here. That's 0, 5. Okay, 1, 0 here. When x is 1, y is 0 here. That's 1, 0. Okay, then 2 -9. 2 -9 here. -9 is actually 2 boxes below -10. This is -10. So 1, 2 going back here. That's your -9. Okay, then 3 -22. That's 3 here. -22. This is -20 here. So you count 4 boxes from -20. That's 1, 2, 3, 4. 1, 2, 3, 4. Yeah, somewhere there. All right, so these are the points that you, and make sure that your points, they are visible. Very visible. These points, they must be visible enough. These points that you're talking about, these ones. So these are the points that definitely that you're going to join properly, and take note here there's a turning curve, there's a curve here, so make sure you join properly. So always I try to make it this way, like to have a curve part here so that I can see what I'm doing properly here. So I'm just going to have my curve here. Okay, that's going to be a turning point there, this point, that's where we're going to have like a turning point there. All right, so here that's what we have then from this point. So you just play around. This is your graph, guys. Play around that graph so that you can draw what you actually have in a smooth way. So as you can see, I'm using a pen, but I'm even having something that is visible. So that's what you're supposed to have. So this is going to be your graph. Then you write down the equation of the graph that you're given, which is y is equal to this is 5 minus 3x minus 2x squared. All right, so you write down the equation of that curve, that one that you give. Then that's it, guys. Then on the same axis, draw the graph of y is equal to 2x minus 3. So this is now a straight line. So how am I going to draw this straight line? Okay, you can use table values, or you can even use double intercept, or depending on what you want. Y is equal to 2x minus 3. So let's just maybe use a table of values. In this case, we've got x and y. So remember, table values, just choose 3 values which are from this values from minus 3, because you're given from minus 3 up to 3, just 3 values of a choice that you want. Okay, so if we choose when x is minus 3, we can choose minus 3 in this case. Okay, minus 3, which is going to be minus 3 times 2, which is when x is minus 3, so it's going to be 2 times minus 3 times, and then minus 3 like that. 2 times minus 3, which is minus 6, minus 3, which is going to give us minus 9. We have got negative, so we are going to take minus 3 when x is minus 3, y is minus 9. Okay, I'm going to choose maybe a 0 here. When x is a 0, I'm just choosing 3 points of my choice. When x is a 0, y is minus 3. Then I can choose this one when x is equal to 2. When x is equal to 2, I'm going to choose 2. If I substitute 2, is 2 times 2, which is 4, then 4 minus 3, which is 1. So when x is 2, so I mark these points, minus 3 and minus 9. When x is minus 3, y is minus 9, that is here, minus 3, minus 9. So this is minus 10. So minus 9 is 2 boxes below, which is maybe at this point. That's minus 3, minus 9, before minus 10. That's 2 boxes going that side. Okay, then 0, 3, 0 minus 3. This is 0 minus 3, minus 3. That's 6 boxes going downwards. 1, 2, 3, 4, 5, 6. That's where you have got your minus 3 here, 3 boxes, 6 boxes going downwards. Okay, that's 0 minus 3. Then 2, 1. This is 2, 1. Remember I said 1 is represented by 2 boxes, so you count 2 boxes going upwards. That's your 2, 1 here, 2 boxes, 1, 2. Okay, then you join your points. That's your line. So to draw a straight line, guys, is simply easy. Points, mark points, then you join those points like that. So you join these points. That's a straight line here. All right, that's what we have, guys. So we're going to have this line, which is y is equal to, okay, let me just write it here. What was the equation, guys? Y is equal to 2x minus what? Y is equal to 2x minus 3. All right, that's gonna be our equation here. So something like that there. So that's what we had, guys. Then let's see on the other part what we are given. Now use the graph, which means everything is supposed to be taken from the graph. The gradient of the curve at x is equal to minus 2. Remember the gradient, guys, I told you that it's on a condition where we are going having this is minus 2. All right, minus 2, guys, at the exact point that you're given, which is at minus 2. So this is our minus 2 here. So this minus 2 corresponds to the graph here, on this graph here. So all you need is to draw a suitable tangent at minus 2. At that point, when x is minus 2 like this, you draw a suitable tangent on this line, on this curve. Okay, so on this curve, what you're going to do is just pick 2 points that you can use which is -2, and the exact point that you're going to choose is the one that corresponds on that curve, which is -2, and in this case that's -2 and 3, because remember from your graph this point was -2 and 3, so you're going to take that as a point and calculate the gradient. So you've got -2. Okay, I keep on taking this marker, guys. Why? Let me put it away. This is -2 and 3. Okay, I choose another point here. I'm just going to take this one on this line that I have drawn, this one. So this one is your reference point. It's supposed to be there on your point because that's where your -2 is, so that at least your answer can be inside the range, in between the range. And this is something like 1, 2. This is minus. Remember, this according to x, you just count direct, which is 1, 2, 3, 4, 5, 6, which is something like -2,6 there. So it's going to be -2,6 versus 0, like that. So using the points that so like I said, it depends with your points. You're just not going to say the gradient that I'm going to have here is the exact gradient, because I drew this graph in a different way. But using your gradient concept, guys, you know, this is your x1, y1, x2, y2. You find your gradient. That's it. So that's what you're going to have there. Then solve the equation. Solve the equation. It simply means, okay, we want to solve this one first. Solve the equation of 5 minus 3x minus 2x squared is equal to 0. So to solve this equation is where this graph intersects with the x-axis, where this graph crosses the x-axis, because this is the graph that we had 5 minus 3x minus 2x squared. 5 minus 3x minus 2x squared. So where this your graph crosses the x-axis, that's your solution, which is at this point 1 here, and at -2, 1, 2, 3, 4 at this point. So it's -2, 4. So x here is equal to -2, 4, or another one is equal to 1 at this point where it crosses the graph. Okay, then solve the equation when this graph now and the straight line. So this graph and the straight line, they meet at this point, because here they do not intersect. This one they do not, so they meet at this point here. So where these 2 points meet, it's gonna be 1, 1 there. That is the corresponding point. So the value of x there is 1, 1. All right, so that's it, guys, because it was supposed to have maybe another value there so that it can be somewhere there. Okay, but now according to the given range that you are given, the values of x from -3 up to 3, and also according to our graph also from -3. So we are not supposed to do adjustments as we answer the question as what is supposed to be done. But in this case, for us to have 2 possible solutions, we're supposed to make adjustments. Okay, make adjustments here, because you know this is supposed to be a curve like this. All right, so now like this is now a curve. They now intersect. So at this point, mark back. Okay, just like that, mark back to this point, which is going to be -3, 1, 2, 3, 4, 5. So it's going to be at -3, 5. So we're going to have -3, 5, -3, 5, or x is equal to, here it's going to be 1, 1. So now we have got 2 possible solutions. So sometimes we have to make adjustments like this one, our curve, make adjustments, because you know that it's supposed to meet with this line so that we can have the actual value of what, of x there. That was the idea of what, that was the idea of the question there. So you must be very, very careful, guys. As you can see, that's how they actually ask, and all you need is to work properly from what you be given from that presentation that you have. And actually on number 11, as your bearing, calculate the length of CD. So as you know, guys, from our bearing, you have to study the angles. Okay, for you to calculate this CD, here there is an angle of 264 and 142 here. So we can calculate this angle inside the triangle, which is 264 minus 142, which is going to be 38 degrees, something like that. 264 minus 130, which is 122. Sorry, guys, I'm taking another angle now, which is 122 degrees, this one. So using this angle of 122 and these 2 sides, you can actually be able to calculate what? To calculate your CD. using what? Cosine rule, because you know that if I'm given two sides and an included angle, I can calculate the third side by this formula: a squared is equal to b squared plus c squared minus 2bc cos a. So that means a squared is the side that I want to calculate, which is cd squared in this case, which is the side cd squared is equal to a squared, which are the two sides 6,2 squared plus c squared, which is the 8,3 squared minus 2bc, which is 6, so like I said, guys, all these like how you simplify and what you're going to have 122 degrees. Make sure that you do them stage by stage until you are going to obtain your cd squared being equal to 161,8697 and so forth. So to find this your cd, remember you have to introduce your square root, and you're going to obtain something like 12,7227 like that. Okay, so to three significant figures, that's going to be 12,7, and these are kilometers. Okay, so it's going to be in kilometers. So that's it, guys. You have to apply your calculators properly, add, and I think I explained all these things, that I think now I'm showing you what you're supposed to do. Actually, on B, calculate the bearing of D from C, correct to the nearest degree. All right, D from C, that is this angle here. D from C, this is your C. So what you do is that you're going to indicate a north pole here at C. All right, so this is what you're going to have. So this is the bearing from C, the north to the angle, this one. This is the angle from the north pole in a clockwise direction. This is what you're going to have here. So as we can see, in order for us to have this angle, there is a comprising of 270, this one, and also this angle. Okay, this angle, if we can be able maybe to know this angle, subtract, but where can we have it? There's no way that we can find it. All right, then also there is this angle here. If we can know this whole angle, this one, if we can be able to know this angle here, let me just write it as theta. Let's say we know this theta here. This one, we already know this one, because remember we said this is 142 here, this is 142. So this angle here and this angle, since this is a north pole, I know that these two angles, they give us 180 degrees. So 180 minus 142, which is going to give us 38. So this is 38 degrees here. Or we can have this as 38 here, and we say this is a Z, this one is a Z. So if this is 38, this is also 38. So this here is what? Is 38 degrees from 180 minus 142 degrees, which gives us 38 degrees. All right. So now I have this angle. If I can be able to obtain this angle, therefore this angle here, the one that I want to calculate as the bearing, is easier, because it's simply 360 degrees minus the sum of these two angles. If I remove these two angles from 360, I have this angle. That is bearing, guys. So which means the theta that I want on my bearing is going to be, let's just call this alpha. The one that I want on my bearing is going to be 360 degrees minus the sum of these two, which is this theta degrees and this 38. So I'm going to subtract this theta and 38, but I have to calculate now this theta. And what am I going to use to calculate this theta? Okay, remember we calculated this side DC and we obtained 12,7 something. So you just write at least 2 or 7, 2 or 3, just write as many digits there. So that is what you had from your CD. So you can use sine rule, because you've got an angle which corresponds the side. Remember, sine rule, angle and a side. Here you've got angle and a side. So you can use sine rule to calculate this angle theta here. Take note, guys, it was actually 5 marks. That is why all this, we have to do this. All right. So let's apply our sine rule. In this case, we know that sine rule is sine A over A is equal to sine B over B, which is equal to sine C over C. Okay, so in this case, it's going to be sine the angle that we want to calculate, which is this theta here. So let's just put as theta. So sine theta over A, which is the corresponding side here, is 6,2, is equal to sine the one that we are given already, this angle that we calculated, and we said is 122 degrees here. So it's sine 122 degrees over the corresponding side, which is 12,7, something like that. It goes like that. So make sure that you just store those values and so forth. I want to calculate theta, so I'm just going to remove this by multiplying by 6,2 so that I can get rid of the what? The fraction. So sine theta is equivalent to 6,2 times this, which is 6,2 sine 122 degrees over 12,723, something like that. Okay. I want to calculate theta, so I can have this as a decimal. Yes, it's fine, which is going to give me 0,413, something like that, which is equivalent to sine theta. So you write every digit until the last one. So theta now is going to be arc sine of that value. So simply from your calculator, arc sine, the answer that you have. So it's simply second function or shift sine answer. Then it's going to give you 24,4 something degrees. So since this is to be written like to the nearest whole number, so let's just save this also to today's whole number, which is something like what? 24 degrees. Okay. So remember, this is theta that we want to subtract so that we can have the bearing here, which we said is going to be 360 degrees minus the theta, the angle inside the triangle. Here we are saying this angle here is 24. So if I subtract this angle and this angle from 360, I'm going to remain with this bigger angle, this one, which is the bearing. All right, so that's it, guys. So which means it is going to be 360 minus 24 plus 38. This is 24 plus 38, which is 360 minus what? Minus 62. So you're going to have 62 here, which is going to give us 298 degrees. So that is our bearing there, 292. So all this working is supposed to be involved. All this working of calculating the theta is supposed to be there. Here was just like doing an indication of what you're supposed to have. Then calculate the distance. D is west of C. D is west of C. When we are referring to the distance when D is west of C, this is what is going to happen here. This is C. So when D is west of C, we are going to have this, or you can even make adjustments here from D like this. This point corresponds with what? This point corresponds to where D is. So we want this distance where D is west of C, this direction here, so that we can have a straight line here, which is at 90 degrees. So this is the line that we want. So at this point here, if you are talking of D, D is west of what? Of C, because this is your C here. And from your C, this is east and this is west. As you can see, D is to the west of what? Of C. So this is the distance that you want to calculate. So you can just call this distance X. All right. So how can I calculate this distance? As you can see, I have formulated a right-angled triangle like this. This is actually a right-angled triangle which is being produced here, where I have got my D here, okay, which is the same, which is corresponding here, and the C here, and I want to calculate this distance, which I'm referring as X, and I'm given this distance of B of this DC, which is 12,723. So that is the shortest distance that you're going to have, actually this one. So how can we calculate this? At least if I have got any angle inside this triangle, let's say I have got this angle, it's going to be easier for me to calculate what? To calculate the side, because I can use my trig ratios because I've got a right angle triangle. But how can I have this angle? Where am I going to have this angle? Remember, these are angles which are having the north and the west line. So this one is a quadrant, which is 90 degrees. So you simply subtract these two angles from 90. Okay, that's 90 degrees minus 24 plus 38. So if I subtract these two angles from 90 degrees, that is what you're going to have in this case, 24 plus 38, guys, okay, which is 62 here. So it's actually 90 minus 62, which is going to give us 28 degrees, something like that. So that's the angle that you're going to work with here as 28 degrees. So that means in this case, if this is 28 degrees, therefore to find X, which ratio am I going to use? Because I'm having this angle. So according to this angle, I want to calculate X, which is the adjacent. I have got the hypotenuse, so I can play around with cos. where I know that cos theta, which is cos 28 degrees, is equal to the adjacent, which is this side that I want to calculate, over the hypotenuse of 2,723. So to find the x, I can cross multiply these two. That's going to be x is equal to 12,723 times cos 28 degrees. So it's now you and your calculator finding the exact value. They make sure that you know your calculator, guys. You must know your calculator very, very well. All right, so simplify the correct to 3 decimal place. Like I said, here I'm just using like the values, but we are supposed to use the exact values there. Okay, on number 12, we've got a question on transformation, and we have got the triangle P, the vertices 1, 2, 3, and so so that was what you have. So you just need to mark these, guys. I don't know if it is going to be well now with the time that you are having. So our triangle P, that's vertices 1, 2. That's 1, 2 here, which is 1, 2 in between. That's 1, 2, 3, 4, 5. Somewhere here, that's your 1, 2. And 3, 2. That's 3, 2, 1, 1, 2, 3, 4, 5. Here, that's your 3, 2 in between here, 3 versus 2. And this is 5, 4. 5, 4, which is 5, 4 here. And 5, that's 1, 2, 3, 4, 5. Somewhere here. Okay, that's 5 here versus 4. So these are the points which are creating the angle and the triangle. Take note, this is just triangle P. It's not triangle like ABC. Don't write it as ABC. Just write the way it is given. All right. Don't give it another name now to say now this is triangle ABC or triangle PQR. No. This is just triangle P like this. All right. That's our triangle P. And here we are given that triangle Q is the image of triangle P under a shear factor. Shear of factor minus 2 with x-axis variant. Draw and label triangle Q. Okay, we know that a shear, that you can write this using the matrix. You can work with the matrix for shear. Okay, and the matrix for shear is given by this Locus, this one. This is the matrix for shear when it is x-axis invariant. When it is axis invariant, take note, when it is y-axis invariant, it's going to be Locus the other way, like this. That is for y-axis invariant. So this is for y-axis invariant, where this k is your shear factor, this one. So it's Locus, like this, Locus. You can memorize that way. That's for shear, where this is your shear factor. Okay, so in this case, your shear factor is minus 2. So you substitute minus 2 in place of k. So you have to list down all these matrices. So I think that's going to be the best way you're going to do. List all so that you can know even how to take them and even to memorize them. Okay, so that's your shear factor, which is 1, 0. Remember, matrix times object gives us image. So matrix for shear, where I have got minus 2 as my shear factor, times the object. The object is this triangle 1, 2, 3, 2, and so forth. 1, 2, 3, 2, 5, 4. Just write this as a matrix. All right. So as we know, guys, row by column. That's row by column 1 and 1, which is 1, minus 2 times 2, which is minus 4. 1 and 3, that's 3, minus 2 and 2, which is minus 4. 1 and 5, which is 5, minus 2 and 8. And 4, which is minus 8. Here we've got 0 on top, so it's gonna be 2, 2, 5. All right, so if you collect these terms, it's going to be minus 3, minus 1 here, minus 3, 2, 2, 5. You just make sure that you take this properly. Now as points, it's minus 3, 2, and this is going to be minus 1, 2, and this is going to be minus 3, 5, like this. So these are the points that you're going to mark. Oh, sorry, like this. These are the points that you're going to draw on your graph. Mark them, then you draw them on your graph, which is the point. Okay, this is for here, guys. Here 1 and 4 here. This is for, guys, before we indicate this. All right, so check note. So now you just need to mark your points properly. So as you can see, mark your points. Minus 3, 2, minus 3, and 2, minus 1 and 2, then you mark your points. That's your triangle Q. So that was the case. Then we move on to this part. I'm just going to be fast because now people are now waking up, guys. So let's be fast. V, which is minus 1, 2, minus 1 and minus 2, somewhere in between here. 1, 2, 3, 4, 5, minus 1 and 2. So you just mark your points, minus 3 and minus 2, minus 3 and minus 2 in the same line here. 1, 2, 3, 4, 5, somewhere here. Minus 3, minus 2, minus 3 and minus 2, minus 5 and minus 4, minus 5 somewhere here, and minus 4, which is 1, 2, 3, 4, 5, alongside what? Alongside this minus 4 here. So it's going to be somewhere there. All right, so you join also your points properly. Join your points properly in this case, just like this. All right, so that's your triangle R in this triangle V. So now you're given that this is triangle V. Draw and label this triangle. So just your triangle V like that. Okay, then it's done. Then you move on. Triangle W is the image of triangle P under a reflection in the line y is equal to x minus 2. Draw and label the line y is equal to x minus 2. So which means you're going to apply double intercept, or you can even use table values, guys, or just ask yourself, when x is equal to 0, what is the value of y? When x is equal to 0, y is minus 2. So you mark a point at minus 2. When y is equal to 0, what is the value of x? When y is equal to 0, x minus 2, x is equal to 2. So x is equal to 2 when y is equal to 0, which means you're talking of the x-axis. So these are the points. So, or you can use double, guys, you can use table values, whatever that you have. So what is important is that the line, you draw it properly like this. All right, so this is going to be my line in this case. I hope it's properly drawn. Okay, so that's our line. Then you just write down the equation of the line, that is y is equal to x minus 2 like this. Okay, so that's the first thing, to draw the line. And we are given that this is triangle W that we are going to draw, which is the image of what? Of triangle W is the image of triangle P. So it's the image of P. So the image of this P, this line. So remember, when it is a reflection, it moves to the mirror line. So this point, let's start with this point, it is going to move 1 unit. This is a standard line, so it maintains, or it creates 90 degrees. So it's going to move 1, then it moves downward 1, 1, 2, 3, 4, 5 at this point. So that's 1 to the mirror line, then 1 going downwards. That's a point. All right, this point is going to move 1 to the mirror line. It creates 90 degrees, it goes downwards, so it move 1 according to scale. This box, this half box, which is 1 according to scale, then you move downwards 1, which is 1, 2, 3, 4, 5. So you maintain 90 degrees when you are moving. Okay, this point is going to move here. That's 1, 2, 3. So according to scale, I'm going to move 3 downwards, which is 1, 2, 3 is somewhere 1, 2, 3, 4, somewhere here. 1, 2, 3, 4, 5. That's 1, 2, 3, 4, 5, somewhere here. That's where I'm going to have my 3. So each point you move a certain distance. 1, 2, 3, 1, 2, 3. Okay, this point 1, it moves 1 down. So you must create 90 degrees like this when you are moving, because it's a slanted line. So these are the points that you're going to just join, just like that. That's how you apply your reflection. When the line is not horizontal or vertical, this is how you do your movements. When the line is not vertical or is not horizontal. All right, so that's what you're going to have here on our so this is our W here. So just name inside, just write inside W. That's just like that. Okay, draw and label clearly the triangle U, the image of triangle P under an enlargement. Scale factor -2 with 4, 0 as the center. Remember, I talked about this enlargement. When you are given a center which is not 0, 0, subtract the center. And as you know, guys, the matrix for the enlargement, now I think you are now used to this matrix K00, K, which is Cook. That is for enlargement. So from your K00, K, I'm going to substitute -2, which is -2 here. So it's -2, 0, 0, -2, like that. That's your matrix. And since there's a center, you're going to subtract the center from where? the matrix P, which is your object, this one, from the object P, this one. So we are going to subtract center. That's 1 2 3 2. You write your coordinates 5 4. Then we subtract the center. Our center in this case, that's 4 0 here. So you're going to subtract 4 0 here. 1 minus 4, that's minus 3. 3 minus 4, that's minus 1. 5 minus 4, which is 1. 2 minus 0, that's 2. 2 minus 0 here, that's 2. 4 minus, which is 4 here. So we have removed the center, and that's what you're going to remain with. And you will multiply now by the matrix for enlargement, which is minus 2 0 0 minus 2. So if you multiply by this matrix, guys, row by column, minus 2 and minus 3, 6 0 minus 2 and minus 1, that's positive 2 minus 2. So you apply your row by column throughout, minus 2 and 1, which is minus 2. Remember, this is a 0, so 0 times this number, that's a 0. So when you add a 0, there is no effect. Okay, the same thing also here, row by column, because you're going to multiply by 0 here, so everything on top is going to be 0 0 0. So instead of writing that, just multiply minus 2 below, minus 2 and 2, minus 2 and 2, it's minus 4. Minus 2 and minus and 2, yes, minus 4. Minus 2 and 4, which is minus 8. So that's it. So when you multiply, remember, matrix times object gives us the image. So this is our image, but when the center of 4 0 is not there, so we have to add back that center that we removed. So our center, guys, was 4 0. All right, so that is our center there. So you have to add, which is, in this case, we are going to have 4 plus 6 plus 4, which is 10. 2 plus 4, which is 6, minus 2 plus 4, which is 2. That's, yeah, something like that. Minus 4 here remains the same. Minus 4 plus 0 the same. Minus 8 the same. So these are the points that you're going to have. Just write them as coordinates now. 10 minus 4, 6 minus 4, 2 minus 8. Then you mark these points now. All right, so 10 minus 2. Let's see where we are going to have this point of 10 minus 4. That's guys, according to scale now, this is not going to be part of, this is not going to work now. This is not going to work, guys. You see, it's not going to work because the scale that we are having and the graph that we are having is actually out of the scale. But if you cross-checked here, it was actually like everything was inside the scale. So sometimes it can be like that, guys, where the part that you have is actually gonna be out of the scale and so forth. So what do you do? Make adjustments. Just leave it like that, because at least we calculate these coordinates. So in this case, our points are going to be out of the scale. There's something like that. Okay, we can even prove this by just doing this this way. Yeah, we can even prove this, because remember, this is a scale factor of minus 2, and our center is what? Our center is 4 0, which is 4 0. That's somewhere here. Yeah, 4 0 is somewhere here. That's your center. So remember, that's your 4 0, which is your center. So from the object, what you're going to do is you join points like to the center. You extend points to the center. Okay, from the center to the, from the point of the image to the center, you extend those points just like that. Okay, this one you extend it also to the center. Our center here is 4 0. Sorry, our center is 4 0 here. So you extend this to the center like that. Okay, then you extend also this one to the center. Just this is our center here. This is our center here. So you extend these ones like that. Okay, so as you can see, that's why, because this one is going to be on this side and it's not there on our graph, because our graph is limited now. So, but that was the idea. With those points, you draw them or you mark them. All right, then on this part, describe fully the single transformation which maps triangle P onto V. And also here, this one is going to be a bigger diagram that you'll be assured that that one is actually enlargement. Okay, where is this happening? P and V. P and V is the one that we drew here. Remember, we drew our V here from our P, and we have got this P and V. So for us to describe these guys, all you need is to join our corresponding points. So this point here, it corresponds with this one, isn't it, guys? So you just need to join our corresponding points here. So that's this point to this point here. All right, this is this point, this one, and as you can see, this was actually like a shifted part, which means this the smaller part, this one is this one. So you join this one, the smaller one. Why? These are isometries, so you have to join, and also the bigger part there with the last part, this one and this point, they are corresponding to each other. This one, okay, this point and this point corresponds. This one, it corresponds with this one. This here, it corresponds with this point here at this point. So as you can see, these are isometries, and you want to describe the transformation. They are isometries, which means the object and the image, they are the same. And I told you that when the object and the image are the same, you're going to expect rotation, translation, and reflection. But since these are now intersecting, when we join, they intersect at this point, it's no longer going to be translation, it's no longer going to be reflection. The last one is what? Rotation. Because translation, reflection, they use what? Parallel lines. It's only rotation which uses where these lines are going to intersect, and this one is a special type of rotation that you must supposed to know. Whenever this happens on a rotation, when these all the 3 points, when they intersect at this point like this, it means that point is your center. So this is how we are going to describe it. So this one, it is a rotation, and that point where they are intersecting here is your center. It's only for this type of equation, when all the points intersect at that point, that will be your center. So this one is our center, 0, 0. And the special type of this is that the angle of rotation is going to be 180 degrees. So the angle of rotation is 180 degrees. It's a special type of rotation which occurs when you are working with an angle of 180 degrees, only for this. Otherwise, if it was 90, you're going to do another adjustment where you have to locate the center and you have to find the angle. But for this one, where these points meet, when all of the points meet at a point like that, that's a special type of what? Of rotation. It's not always like that, and it only happens when you are working with what? With isometries. That's where we have got rotation. So guys, that's what we had from this question paper. I think we can have 1 or 2 that we can work on, and the areas that we left, that we said we're gonna work on them separately, that's what we are going to do. But for now, let's have what is clear, and let's work on them and revise as much as we can. But that's what you're having, guys, from Mason African Motives. And don't forget, family, to share our videos and also to invite others to our platform, guys. Let us continue to do so. Invite others, as many as we can, so that we can learn as a family, grow as a family. The more we grow as a family, the more we bring things which are actually like stuff that is actually better because of the growth that we are going to have. And also the other thing, I think I talked about this, that we are still working on more resources so that we can have effective classes and effective videos that we shall have, that we need us to work on. So as we grow as a family, it helps us also to create all those things. So for now, till we meet again.